everyone, my name is Suwijai. Hello everyone, my name is Suwijai Chai. I'm a master degree student in Geology of Chiang Mai University. Today, I would like to talk about the tectonic setting of the metatarth in the mapped Salient Union Unit, Kanchanaburi Province, Western Thailand. Let's start with the introduction. So the area is located in the Mueang District, Kanchanaburi Province, which belongs to the internal suture zone that represents the Paleothetis. This thetis was located between the Cebu Massif and Indochina terrain. However, the internal suture zone is not only Paleothetis remnant, but also includes the tasselite of the Cebu Massif basement. Moreover, these metatarths have been published the second age dating. They were emphasized in the Cambodian related to the subduction of Paleothetis. This figure is show geologic map of the study area that consists of Cambrian, Ordovician, Silurian, Devonian, Triassic, granite, and unconsolidated quaternary. This study focused on the Silurian Devonian unit represented by the brown area. The details of petrography and geochemistry of this rock are still unclear and insufficient. Therefore, we report the petrographic and geochemical data. Move to the petrography. The metatarths can be classified as the metaport, feldspar, fissile tuff, and metallitic tuff. They were made up mainly of verified to coarse-grained volcanic particles or pyroclasts, and perhaps mixed with non-volcanic particles or epiclasts embedded in a highly altered vitrified fine ash matrix. Move to the geochemistry. Based on the immobile element classification post, the metatarth can be classified as trachyandesite, dacite, and levolite. And the condyle normalite rare earth element pattern display the lightly enrichment with nearly flat of heavily and show the negative European anomaly that is typical for the calc-alkali volcanic rock. This shows the primitive mantle normalized spider diagram. The metatarths show the negative niobium tantalum anomaly, which indicate the magmatic arc signature. Move to the tectonic setting. Most samples fall into the volcanic arc granite field in the granite discrimination diagram of PS 1984 using the rubidium, niobium, yttrium, tantalum, and ytterbium. And like with the discrimination diagram of Wood 1980, all samples fall into the calc-alkali basalt. That also relate to the subduction. In the conclusion, the metatarth from the Kanchanaburi were emphasized in the late Cambrian to early Ordovician. They are trachyandesitic, dacitic, and leolitic tuff, and belong to the calc-alkali series. The tuff were formed in an island arc environment related to the Proto-Cretaceous ocean subduction. Thank you for your attention.
Hello all folks, thank you for your interest in this research. My name is Said Santitarangkun, graduate student from Department of Geological Science, Faculty of Science, Chiang Mai University. In this section, I am going to talk about characteristics of igneous rocks from the Sukhothai zone during the late Permian to early Jurassic, evident for changes in formation depth by trace element content. Formation and emplacement of magmatic rocks are well documented in the Sukhothai zone in Southeast Asia during Permo-Triassic to early Jurassic times, approximately 250 until 180 megaamna. The observed magmatism in Sukhothai zones point to long life subductions with zinc corrosion and pores corrosion events. The geochemical data igneous rocks from southern China, northern Thailand, and northwestern Laos in order to document the changes with time at which crustal level partial meltings occurred. Strontiums, yttriums, lanthanum ytterbiums, and holmium ytterbium ratios in igneous rocks are sensitive to depth of melt formation due to the presence or absence of high pressure mineral such as garnet, amphibole, or another. This ratio rise with depth formation, thus indicating increasing crustal thickness. Therefore, those ratios were used to reference change in crustal thickness and hence depth of magma formations. And I use the equation that calculates Mohodovich is 1.1 of strontium near ytterbium ratio plus 8.5 kilometers or calculate the depth in kilometers. Hello all folks, thank you for your interest in this research. My name is Said Santitarangkun, graduate student from Department of Geological Science, Faculty of Science, Chiang Mai University. In this section, I am going to talk about characteristics of igneous rocks from the Sukhothai zone during the late Permian to early Jurassic, evident for changes in formation depth by trace element content. Formation and emplacement of magmatic rocks are well documented in the Sukhothai zone in Southeast Asia during Permo-Triassic to early Jurassic times, approximately 250 until 180 megaamna. The observed magmatism in Sukhothai zones point to long life subductions with zinc corrosion and pores corrosion events. The geochemical data igneous rocks from southern China, northern Thailand, and northwestern Laos in order to document the changes with time at which crustal level partial meltings occurred. Strontiums, yttriums, lanthanum ytterbiums, and holmium ytterbium ratios in igneous rocks are sensitive to depth of melt formation due to the presence or absence of high pressure mineral such as garnet, amphibole, or another. This ratio rise with depth formation thrust indicating increasing crustal thickness. Therefore, those ratios were used to reference change in crustal thickness and hence depth of magma formations. And I use the equation that calculates Mohodo, which is 1.1 of strontium near ytterbium ratio plus 8.5 kilometers for calculate the depth in kilometers for the borehole images. The subduction phase started in the late Permian and went at Middle Triassic times. Geochemical data which indicates in high of those ratio allow documents of crustal thickenings formations of melt at high depth at around 250 until 240 megaamna. This event is also associated with the closing of non-Uttaradik backyard basin. The liolite sample from Chiang Khong area might be product of an arc to synchronization tectonic setting around 240 megaamna. This one. At approximately 240 to 220 megaamna. Lower of those elements ratio occur. It indicates shallower melting depth related to crustal thickenings and extensional in this time. However, igneous rocks with intrude around 220 until 215 display slightly evaluate ratio, indicating a deeper source of kinetic magnetisms if compared to 240 and 220 megaamna. The last one is extensional and thickenings of continental crust occur during early Jurassic, confirmed by lower of those elements in this period. And while comparing with the relationship of compressional event and extensional events on the basin formation and metamorphisms in northern Thailand, were found that extensional events approximately 240 until 220 megaamna was related to Lampang and Songkups in this area. The compressional events around 220 to 215 megaamna related with the high peak of metamorphism in northern Thailand. And the last one is the extensional of continental crust occurred during the early Jurassic, associated with the deposition of Mesozoic late bed in northern Thailand. The changes in depth of magma formation from the late Permian to early Jurassic in Sukhothai zone is consistent with the transition of volcanic arc into a post-corrosion extensional development, which is related to cross of the Paleoclastic Ocean. Thank you for your attention. And if you have a question, please feel free to comment in this section. Thank you.
Good morning. Anybody would like to test their system, especially for the presenters or the chairman?
announcements just in case. Please check that we have the upload the updated program on the chat. If you happen to use the chat in a Zoom application, so you're going to see the updated program uploaded, available for you. There may be some change in the program as well, which still some of the presentation, I think it's only one presentation, may not be able to do that today. That's the afternoon one, so I'll let you know later. We still have a few minutes to go, just in case anyone would like to test your presentation. Please let us know. Thank you. And so I think maybe what I'm holding, I don't know whether is it possible to zoom to. Okay, this is even though this is a hard copy of the last year thematic session proceedings, it will be available online, digital file only. This year is special because we don't have any publication in as a hard copy, but it will be available online for everyone if you would like to have it. Okay, it's already available for us. Yeah. Just a quick announcement, right? This is an example only. Okay, don't ask for hard copy because we don't have it. Thank you very much. Good morning, everyone, and welcome to our second day of the CCOP 2020 thematic session. Sawasdee krap. My name is Titi Tulayatit, regional expert at the CCOP Technical Secretariat Office. Today, we continue with our presentations. As I mentioned yesterday, for the poster presentations, we will try to put it on during the lunch break from 12:30 onward, and also, if possible, at the coffee break in the afternoon. Today, we have the session 2 on groundwater geodata and information, geoenvironment, climate change, hazard, and urban geology. And today, for this morning session, we have 2 chairpersons. The first one will be Dr. Toshihiro Ushida, leader of International Coordination Group, Geological Survey of Japan, our very old friends of CCOP. And the other person will be a co-chairperson, which is Dr. Manussawi Heng Suwan from the Royal Thai Department of Groundwater Resources, Thailand. I believe that Dr. Toshihiro Ushida is very well known for us. So for Dr. Manusawi Hengsuwan, she got her bachelor and master degrees in chemistry and also a PhD in geoscience from George August University, Göttingen in Germany. And she is very fluent in both German and English. So please, I would leave the floor for Uchida-san and also Dr. Manusawi Hengsuwan. Please, thank you very much.
Good morning. Thank you, Dr. DT, and good morning, everybody. As DT said, I'm an old person. Okay, we have 8 presentations in this session today. So, first 4 papers speaker. Speak off. Sorry. So, first 4 paper with chair by the Manusawi, then last 4 with by myself. Just a quick announcement. Okay, sorry. So each paper has 15 minutes for presentation, but at 10 minutes, I will ring this sound to on for 5 minutes left. On the Zoom meeting, it's difficult to raise a question, but please, I encourage you to put your question in the chat box. We can respond on that. Okay, I will give the Dr. Manusawi for chair first paper.
Okay. So can you hear me? Okay. So let's get started with the first presentation. The first presentation will be presented by Mrs. Siti Liana Moj-Afri. And the title of this presentation is Groundwater Exploration through 2D Electrical Resistivity Tomography in Labi Agricultural Site, Belet District in Brunei Darussalam. And for this presenter, she is now the PhD student in University of Brunei Darussalam. So please welcome Mrs. Siti Liana Moj-Afri.
Hi, hello, good morning, everyone. My name is Liana. Thank you, Ms. Chairperson, for the introduction. I am a PhD student from Geosciences Department of University Brunei Darussalam. Let me first say thank you to CCOP for the opportunity to present this research in this prestigious event today. This is the first for Brunei to participate in the CCOP annual thematic session, and we look forward to participating in more sessions to come. Now, this research that I will be presenting today is one of Brunei's recent achievement and advancement in the agriculture sector as well as groundwater industry. The research topic is groundwater exploration through 2D electrical resistivity tomography in the Labi agricultural site, Blight district of Brunei Darussalam. And this research is a collaboration between the Geoscience Department of University Brunei Darussalam, Department of Agriculture and Agri-Food, as well as Preston Geochem Brunei, a groundwater consultancy company. Okay, the presentation outline are as follows. I will be going through the introduction of the study area, followed by brief regional geology, our research methodology, our results and discussion, as well as the conclusion. Now, Brunei is located on the northwestern part of Borneo Island, overlooking the South China Sea, and the country shares a border with Sarawak and Sabah. The study area is located in the Belait district, the largest district on the southern part of the country. Brunei's climate is typical of equatorial tropics. Brunei is generally hot with wet and dry seasons throughout the year. Okay, next slide, sorry. Okay, now the map is showing the study area, the Labi agricultural site. Now the map shows the location of the borehole, which is called the well L1, and the ERT survey line, ERT L1. More than 99% of water supply in Brunei comes from surface water resources, including the water supply into the agricultural sites. Over the years, there has been an increase in population and demands in the agricultural sector. And efforts have been made to improve irrigation as well as increase crop production in the country, which have led to groundwater exploration and investigation as an alternative water supply for irrigation purposes. However, groundwater resources in Brunei are currently underexplored. There are very limited information known about groundwater flow system or groundwater understanding in Brunei. So therefore, this study is fundamental to understand the hydrological conditions in Brunei and in other similar geological settings. The study objective is to conduct groundwater exploration works at the Labi agricultural site. Groundwater is to be used for irrigation purposes. We achieve this by conducting geophysical imaging using the ERT, electrical resistivity tomography. It helps us to map subsurface lithology and structures, understand variation in resistivity, delineate potential groundwater zone. The second phase we did was borehole drilling and pumping tests. We conducted borehole lithology to also validate the resistivity, conduct pumping tests at the new well. We evaluate aquifer characteristics and also suggest proper recharge measure for sustaining groundwater supply in the study area. The photos on the right were taken from the Labi agricultural site. The study was conducted near the Labi paddy field. Now, I would like to share a brief regional geology of Brunei. Brunei is based on, the study is based on previous research and literature. Now, the Brunei Basin is made up of several rapidly prograding delta systems that evolved since the Miocene period. Three major deltas recognized: the Malagan Delta, Champion Delta, and the Baram Delta. Based on the study area lies within the Champion Delta. This delta evolved sometime toward the late Middle Miocene to early Pliocene. Here we have the lithostratigraphic map of Brunei, showing variation in lithostratigraphy of the study area indicated in yellow and the surroundings. The sediments found in Brunei Basin is composed of thick siliciclastic sediments that is part of the prograding and aggrading delta sequences that I mentioned in the previous slide. Now, the study area, as seen on the map, lies within flat-laying recent deposit. This type of deposit is made of clay and sand, and in some areas also overlain by peat. In this study, we present a geophysical technique, the ERT, short for electrical resistivity tomography, which is commonly used for subsurface imaging and investigation. Now, there are a lot of studies and papers on ERT for groundwater exploration globally, but this technique in Brunei is new and it has never been done before. So the ERT is a direct current method. It uses the electrical resistivity measurements made at the surface by deploying the resistivity equipment. And from the field data acquisition, we were able to produce 2D inverted resistivity model as seen on the left side of the slide. The photos on the right were taken during the field data acquisition at the study area. The photo shows another close-up of the resistivity equipment that were used. This includes the abiometer, batteries, cables, and electrodes. The ERT length conducted in the study area is approximately 400 meters. The array that we use is the pole-dipole array. We use the software ZoneRes 2D to display the 2D resistivity model. Now, this model, it helps us to investigate the subsurface structure as well as the potential groundwater zone. Based on previous studies and literatures, different types of materials such as clay and sand, or different types of water such as seawater and groundwater gives different range in resistivity reading, as you can see from the table. So we use this understanding to help us interpret our results. Borehole drilling of well L1 was successfully conducted on 16th of July 2020, and the drilling depth is 80 meters. We conducted soil sampling as well as soil investigation every 3 meters during drilling. We were also able to construct the borehole lithology log. The photos shown on the right were taken during the drilling phase. The photo shows a drilling rig and some samples that were gathered from the well. Once we have drilled and constructed the tube well, we proceeded with installing a submersible pump for pumping tests. The test includes a 24-hour constant rate pumping test, recovery test, and the data recorded includes time, water level, and water discharge, which was later used to estimate the aquifer characteristics. We were able to estimate the transmissivity as well as the hydraulic conductivity. The photos on the right were taken during pumping tests. The 24-hour constant rate pumping test requires the team to stay on site during daylight as well as overnight. Now, the 2D inverted resistivity model revealed variation in resistivity in the study area. The depth of investigation is 100 meters along a 300-meter line. The color variation, as you can see on the screen, represents the different variation in resistivity readings. So in the study area, the resistivity ranges from 5 ohm meters to 700 ohm meters. Based on the 2D model, we were able to interpret two distinctive layers. The first layer is interpreted as the topsoil. This layer has a high resistivity between 100 to 700 ohm meters. The depth of the layer ranges from 10 to 40 meters. The second layer is interpreted as the groundwater potential zone. Now, this zone consists of low resistivity ranging from 5 to 100 ohm meters. The depth of the layer ranges from 20 to 80 meters. One well was successfully drilled through the groundwater potential zone in the anomalous area found on the northwestern side of the study area. The target depth for drilling is 80 meters. The borehole and soil investigation revealed the type of rocks found in the study area. On the left side of the slide, we have a borehole log with the borehole lithology description from 0 to 80 meters. Borehole lithology, it helped in resistivity readings. So the topsoil, it has a high resistivity, corresponds to gray clay with traces of silty fine sand and gravel. The groundwater potential zone with lower resistivity ranging from 5 to 100 ohm meters corresponds to interbedded sandy clay, fine to medium sand and sandstone. Pumping test analysis was conducted to evaluate the aquifer characteristics. The time drawdown cross plot is presented here. As shown on the graph, both the 24-hour constant rate as well as the recovery test results are plotted. From the test, we were able to pump at a steady rate of 288 meter cubes per day, equivalent to 12 meter cube per hour. Transmissivity is one of the important hydraulic properties of an aquifer. It shows the ease with which water can flow through the aquifer. Now, we estimated the transmissivity value using the unsteady Cooper-Jacob formula for confined aquifer. The calculated transmissivity value is 109.8 meters square per day. Based on literature review, this value corresponds to moderate aquifer potentiality.
A minute.
Okay, thank you. Transmissivity of an aquifer is also related to the hydraulic conductivity through the following formula: T equals to K multiplied by the saturated aquifer thickness. Now, we estimated the hydraulic conductivity value using the following formula, and the calculated hydraulic conductivity value is 1.83 meters per day, or equals to 2.1 times 10 to the power of -5 meters per second. Now, based on previous studies, this value corresponds to alluvial or fine sand deposits. Now, in conclusion, 2D resistivity model revealed groundwater potential zone with resistivity readings from 5 to 100 ohm meters at depth of 20 to 80 meters. The 2D resistivity model were also used to identify suitable groundwater prospects for borehole drilling. Well, L1 was successfully drilled to depth 80 meters below ground level. Now, based on borehole lithologies, the groundwater potential zone is made up of fine to medium sand, sandy clay, and sandstone. Based on pumping test analysis, the well was able to be pumped at a steady rate of 12 meter cube per hour. Aquifer characteristics that were estimated based on the constant rate and recovery test analysis conclude that the transmissivity is 109.8 meters squared per day, and the hydraulic conductivity is 2.1 times 10 to the power of -5 meters per second. Now, this pilot study presented the resistivity dataset and the borehole lithology. Now, it has provided sound knowledge of the subsurface geology formation and structure within variation in resistivity within the study area. The present study helped in realistic conceptualization and understand the hydrogeology conditions in the study area, as well as in areas with similar geological settings. So decision makers are able to make or to take suitable measures for placing future irrigation wells and to understand proper recharge measures for sustaining groundwater supply in the agricultural sector. Okay, that is all from me. On behalf of the team, I'd like to say thank you for your attention and open the floor for question and answer session.
So thank you very much for the interesting presentation. I have one question. Did you check the groundwater quality from that well that you drill?
Yes, since this is a pilot study for Brunei, we also managed to sample groundwater samples from the aquifer and also conduct geochemical analysis looking into the properties and the quality of the water, whether it's suitable for irrigation and so on.
Okay, because I just looked from the map and I saw that your study area is actually not too far from the sea. And yes, and if you pumped groundwater a lot for irrigation, it may change the groundwater quality.
Exactly, yeah.
So I think I would like to suggest to monitor this groundwater quality from this well as well. Yeah.
Yes, correct. Yeah. Thank you for the question.
Okay. Other question from the audience?
We have one.
Okay.
May I have
please, Dr. Yoshida.
Oh, thank you very much. Nice talk. Have you done any logging, geophysical logging, to compare with DC data to electrical logging?
In the study area, we didn't do any geophysical logging. We only look into the ERT resistivity results. Yeah, just only based on the ERT.
Yes, I want to know the relation with resistivity of sandy layer and clay layer, and to distinguish the aquifer. That's my comment.
Yeah. We're looking into that. Yep.
Thank you.
Thank you.
Any question? Okay, so then no question. Then thank you very much, and please give a big applause to.
Thank you.
Thank you. Now we will move to the next presentation. The title of this presentation is CCOP GSJ Groundwater Project and Sub-Project for Ground Source Heat Pump System Application. And this presentation will be presented by Dr. Gaurav Shrestha. He is right now a principal researcher in Japan. So please welcome Dr. Shrestha.
Unmute your mic, Shrestha-san.
Sorry. Thank you, Chairperson and Co-Chairperson, and all those CCOP technical TS and DMR staffs. So I'm Gaurav Shrestha from Geological Survey of Japan, AIST in Japan. So today I'm going to present on the CCOP GSJ groundwater project and sub-project for ground source heat pump system application. So starting with the background of our CCOP GSJ groundwater project, Firstly, this project was started in 2005, which was the phase 1, and until now, 3 phases had been completed. So those of the I'm sure that many of you who are associated with these groundwater projects are know about these phases as well as the works that had been carried out during these phases. Just I'm giving the overview. So last year in 2019 December, we just kicked off the phase 4 of this project. So regarding the groundwater database and its construction and design, in mainly focusing on for the CCOP groundwater, the phase 2 has started in 2009 with the main theme of renewal of database for hydrogeological maps in CCOP regions. And the aim is to compile the data of Chao Phraya Plain of Thailand and Red River Delta of the Vietnam. So on the right side, you can see the groundwater database, the water environmental map of Chao Phraya Plain conducted during the phase 2. And these are the data that have been collected from the field survey during that phase 4 and compiled as the database. But these databases are limited to only, as I said, Chao Phraya Plain of Thailand and Red River Delta of Vietnam, and only published in the CD-ROM data, so not open and to the web-based and not accessible. So with this issue, phase 3, to solve these issues, the phase 3 of the groundwater project was started in 2014 with the objectives to develop web-based groundwater database of the member countries using the Open Web GIS system, and also commence a new sub-project of ground source heat pump application using this database. So in this phase 3, member countries were divided into 3 groups based on their observation system of groundwater and the data availability. So here you can see database 1, 2 groups and public policy groups. So regarding DB1 and DB2 groups, like they share the common points, like they have the observation system already installed and the groundwater data has been already monitored. For DB1, the groundwater data has already started to be compiled, but for DB2, groundwater database doesn't exist. And for public policy group, no groundwater observation system in the countries. So we focused on, in phase 3, we focused to construct the database of these DB1 and DB2 groups while compiling the groundwater data, and for DB1 converting the groundwater data to the CCOP database. While the public policy group mainly focused on attending KGAM's groundwater program, attending GSJ's WebGIS program, and make an effort for the groundwater observation system. And we heard, luckily, we say, how to say that, we heard the good news that during the second half of this phase 3, the Cambodia and Lao PDR constructed the groundwater monitoring wells supported by the CCOP KIGAM project on groundwater monitoring wells. So we hope that in coming days, we will get more data from public policy group as well, which I'll also talk in the phase 4. So regarding the platform to compile and update our CCOP groundwater database, we collaborated with the CCOP Geo Information Sharing Infrastructure for East and Southeast Asia GSI project to upload and compile our groundwater data. So this is the GSI portal of this project. I'm sure that many of you are familiar with this GSI system as well as this project. So here we can see the groundwater database in the available WebGIS portals. That means we have created the CCOP groundwater portal in this page, and our groundwater database construction was being coordinated by the leaders of GSI project, Dr. Shinji Takarada and Dr. Joel Bandibas. Actually, I'm very thankful to Dr. Joel Bandibas for his immense help, because he himself formatted all the data as well as, and also like uploaded the data in the portal. So here is the groundwater portal, and it looks like this. Currently we have the groundwater data. You can see the observation points are groundwater wells from the 7 member countries. And we can access the groundwater portal from this link as well and see the available data. So to be in quite like little detail, like if we click the location points, we'll get the groundwater information like this. And in this GSI system, like we can link different kinds of like water quality graphs and maps. Now, in this case, we have shown the stiff diagram of the location where the water quality has been measured or monitored. Likewise, for the Vietnam around Hanoi city, we also created this kind of database or compiled the groundwater information. And in this case, we can show the water temperature graph, like the vertical profile of water temperature graph by clicking the show water temperature graph dialog box. And these graphs and these geo informations are very informative and important for not only this project, but also our sub projects like ground source heat pump system application. So these are the major outcomes of phase 3. So we were able to compile the groundwater data of around more than 4,000 groundwater wells from 7 countries. So besides groundwater, we also published the technical report of the CCOP groundwater project phase 3 groundwater GW9 with around 200 pages containing these contents. So next, I'll talk about the sub-project for ground source heat pump system application. Here, I'll just give the brief overview of this project because my colleague, Dr. Arif, will present about the detailed analysis result after my presentation. So this sub-project was started from April 2014 with the objective to demonstrate the heat pump, ground source heat pump system in CCOP regions or Southeast Asia. And also, as the Southeast Asia is the tropical region, so we need to find out some adjustment and modification needed to be applicable in CCOP member countries, and also to develop suitability maps for installation of ground source heat pump system using regional scale groundwater flow and heat transport models. So in this sub-project, we had very highly cooperated by Chulalongkorn University, Department of Mineral Resources of Thailand, and Vietnam Institute of Geoscience and Mineral Resources of Vietnam, and BPPT Indonesia, as well as Akita University of Japan and JICA. So the first installation or demonstration of ground source heat pump system was conducted in Chulalongkorn University at Parrot Raja building, the President House in the Bangkok campus. So the middle figure is the system configuration where we use the borehole type, 2 borehole type heat exchanger system for the space cooling of this office room of the Parrot Raja building. So beside this Chulalongkorn University, we have other demonstration sites in the Saraburi campus of Chulalongkorn where we use horizontal type heat exchanger in 2015. And in 2016, we installed borehole type heat exchanger or heat pump system at DMR National Geological Museum. And in the same 2016 at the Vietnam and in Indonesia, we were able to construct a borehole heat exchanger only, but in the future or in coming days, we expect to install demonstration the GSHP system.
So we have now 5 minutes left.
Thank you. And I just want to say that we have been continuously evaluating the performance of these systems. And in this graph, the COP means coefficient of performance means the thermal output divided by power input. And we are also analyzing the benefit of GSSP system by finding out the electricity reduction by this system compared to the normal air conditioner system. And we found that in Bangkok campus and Saraburi campus, the electricity reduction can be from 28% to 35%. And also in Saraburi campus and Bangkok campus, the performance is quite high, while in DMR and BIGMR, this performance is quite average. So we are continuing the evaluation from now onwards also. So one of our other objectives is to make the suitability map for the installation of ground source heat pump system. And this is our pilot suitability map for the lower Chao Phraya plain, which we developed with the help by conducting the groundwater and heat transport analysis using this model. So in the future, we are also trying to develop this kind of maps in Vietnam, Indonesia, and our member countries also. So these are the just reviewed papers, just the list. So regarding the phase 4, it was kicked off on December 2019 after completion of phase 4, and the major objective is to update and improve CCOP groundwater database. So our plans are like groundwater data public policy group will also be added in this phase, because in the phase 3, we have the groundwater database of these countries only, which is DB1 for phase 4. Now the DB2 in this phase 4, like Cambodia, Laos, Mongolia, and PNG, Myanmar, the database collected from these countries will be uploaded to the current database. And we are also planning for a one-day workshop or training on GSI system to upload and edit the groundwater data by each member country, because this is very important to maintain the data quality that are uploaded in the database. And this will be supported by our GSI project coordinator, Dr. Joel. We will also conduct field survey and discussion to solve groundwater pollution problems in these DB2 countries. So we'll continue with the sub-project. And other additional items, data items that could be useful for studies on land subsidence and groundwater pollution problems will be added. And these are the recommended parameters that were suggested by the member countries during our last meeting. But unfortunately, this year, next project meeting was supposed to be held, in Naypyidaw, Myanmar in the early 2021, but because of COVID-19, we have to cancel it, and we hope for we will able to hold the project meeting next year. However, we will publish the project report GW10 by compiling the country reports presented by each member countries in the kickoff meeting. So this is just the conclusion as listed. So here I'd like to conclude my presentation. Thank you very much for your kind attention.
So thank you very much. Any question? Okay.
Dr. Panya from Chulalongkorn, not from Chulalongkorn University, used to be at Chulalongkorn University.
Yes, sir. Thank you very much for your cooperation.
I would like to mention here is it seems to us that groundwater level, groundwater database is quite important. What you haven't mentioned much about the what kind of groundwater level or what kind of groundwater database. Is that important for the groundwater flow, and which area that groundwater cannot be used quite well for or limitation of groundwater, particularly in the case of arid region where you get really deep groundwater level. So in this case, that means not all area can be we cannot use geo heat pump or ground source heat pump sufficiently.
Yes.
Is it true?
Yes,
In
it's true.
Bangkok, we don't have any problem. In Srinagar, we don't have any problem. What I'm afraid is in Khon Kaen, where some place where you got a quite deep groundwater level. Would you please explain a little bit more for this?
Sorry, sir. Do you mean the Khon Kaen province? Right now, like we have for the Chao Phraya plain, we already did analysis about the groundwater flow modeling also. So for Khon Kaen province, as you said, the groundwater level is quite deep. So with that perspective, it's like demerit for the ground source heat pump system application because it's a shallow one. But it's not that everywhere it's deep or shallow. First, we have to find out. So based on the data provided by the Department of Groundwater Resources, Thailand, we are planning to do some, maybe if possible, with cooperation with DGR and also Professor Panya, maybe we can do groundwater flow analysis of Khon Kaen province, like we did for Chao Phraya plain. And not only the groundwater level, but the groundwater velocity is also important for the GSSB system application. Because with the higher velocity, the heat transport will be very essential for the application of and good performance of the heat pump system. So I think we should do some modeling, simulations, flow analysis in coming days.
Okay, what I would like to comment again is that at Khon Kaen University, there is a kind of what they call the groundwater research center. So in that case, you may go there and then talk to them. They probably have a very interesting story, particularly for the groundwater system in the Northeast. That's my comment.
Thank you very much, sir.
You're most
Maybe
welcome.
if we start some project in Khon Kaen or demonstration site, we'd like your support in coming days as well. Thank you very much.
Okay, thank you, Sresa-sang, for your nice presentation. I'm Young-Ju from CCOP. Actually, I just comment that I really appreciate all the effort done for the phase 3, and then you have a new phase 4 in groundwater project from Geological Survey of Japan. So by using this opportunity, I really appreciate your support from you and Yohei-san for the dedicated contribution to the CCOP. And I also hope that as we discussed, groundwater source heat pump is a quite important project which can be applied to other member countries also. So I really hope that for coming years, we try to find out some opportunity to have some kind of workshops which invite all our member countries to have some possibilities of that technology applicable to our member countries. Thank you.
Thank you, sir.
So more question? Okay, so now the time is up, and then we will move to the next presentation, which is related to the ground source heat pump. And the next presentation is the research on ground source heat pump application in Southeast Asia under the CCOP GSJ groundwater sub-project. This presentation will be presented by Dr. Arif Moyo, and he is so then please welcome Dr. Arif Mojo.
Thank you. Thank you, Ms. Chairpersons. Good afternoon. My name is Arif Mojo from Geological Survey of Japan and Renewable Energy Institute of AIST, Japan. And today I'm going to talk about our research collaborations on ground source heat pump application in Southeast Asia under the CCOP and JSJ groundwater sub-project. So this is my presentation outline. So first, I would like to briefly introduce what is GSSP itself. So I think many of us still doesn't know about what is exactly the ground source heat pump system. And secondly, I would like to talk about briefly about the energy, the relationship between energy, economic growth, and space cooling in Southeast Asia, challenges on GSSP application in Southeast Asia, CCOP, GSD sub-project on GSSP and application in Southeast Asia, our current results, future works, and finally the conclusions. So first of all, what is exactly the ground source heat pump system? Naturally, the heat is flowing from the high temperature reservoir to the lower temperature reservoir. Like, for example, if we hold a hot coffee, so we will feel hot because of the heat is being transferred between from the hot coffee to our hands. On the other hand, we can actually reverse the process by a means called heat pump. The example of heat pump itself is most of us have it now, like for example the refrigerators and also the air conditioning system. While the terms ground source itself there is a difference between how we exchange the heat from the conventional air conditioning system, where we exchange the heat to or from the outside air, from the atmospheric air to the ground in case of ground source heat pump system. So as we can see in the right hand side here, there are many kind of configuration we can do with the ground source heat pump system, with the vertical boreholes configuration, shallow horizontal configuration, or if we have open water, for example, pond or lake, we can use it to exchange the heat. And also the open loop system, where we pump directly the groundwater, we flow it through the heat exchanger and then flow it back to the ground. And also very efficient one, the energy pile system, where we install the ground heat exchanger together with the pile foundation system for the buildings. And the energy and economic growth in Southeast Asian country, recently we found that regional growth of economy has been increasingly high. And we also found that there is a strongly positive relationship between the per capita of GDP growth with the per capita electricity consumptions growth. While it is forecasted that in 2040, the electricity demand will be about twice from current state, where most of the capacity will be used for the building or residential, especially for cooking and also for cooling. And as we can see here that from 2011 to 2016, that there is a continuously increasing demand of air conditioning in Southeast Asia, in Asia, except Japan and China, where most of these countries are the Southeast Asian country. We can see also that still the number is lower than China, for example, and North America, but we can see that the number is quite steadily in other regions, while we have experiencing the increasing demand in the Asian regions, except Japan and China. On the right side graph, we can see that the relationship there is no exact relationship between CDT or cooling degree days with the number of the introduction of the share of household using the air conditioning system. We can see here that Malaysia, for example, and Singapore has very high penetration ratio. 80% of household, they have air conditioning, but we can see that less than 10% maybe, or 15% of household has air conditioning in case of Philippines, Indonesia, Vietnam, and Cambodia. But still, if we consider about the growth of the economic, so still we have emerging market in this area. So the question is, can actually the ground source heat pump system plays important roles on space cooling in the future in Southeast Asia? So speaking about the ground source heat pump application in Southeast Asia, we face many obstacles. For example, in financial point of view, we have problem in the high investment cost, the upfront cost, and there is still no existing market of ground source heat pump system currently in Southeast Asia, and the electricity price is quite low compared to other countries like Japan, for example, because of the subsidy from the government. And from the technical point of view, we use only ground source heat pump system only for cooling, means that we continuously reject heat to the ground. If we consider the four season country, there is a balance between heat rejections and heat extraction during winter period like now in Japan. And also the background temperature is already high, and there is lack of GSP performance data in tropical regions. In terms of social, we have a lack of information of GSP system and lack of awareness of energy saving from the people. And in terms of government, there is no currently government incentive, of course, for introduction of GSP system, and very limited government policies to accelerate the use of high efficient appliances, for example, air conditioning or so on. But we have here accelerating factors, for example, positive and rapid economic growth, the increasing awareness of energy saving. And still, we have also high rainfall rate, which we expect to be very good to stabilize the temperature, ground temperature. And also the conventional heat pump system is actually mature technology. The heat pump currently sold is actually in the mature. The technology is already mature. Like what have been explained by Dr. Sresta previously, so we have currently 4 installed systems, 3 in Thailand and 1 in Vietnam. In Thailand, Chulalongkorn University, we have 2 system, vertical heat exchanger and horizontal heat exchanger in Saraburi campus, and also in Department of Mineral Resource of Geological Museum of Department of Mineral Resource of Thailand with a vertical heat exchanger. In Vietnam, we have in Vietnam Institute of Geoscience and Mineral Resources in Hanoi. While in Indonesia, we have finished to install the ground heat exchanger. We do hope in the future after this COVID-19 over, so we can continue this project. And these will be very important for analysis, especially performance analysis, system improvement, development of numerical simulations, which will be eventually important for the optimization purposes, applicability studies, cost analysis, and demonstration sites of the technology to the people. This is one of the results from the Geological Museum of the Department of Mineral Resource of Thailand. So we focused in this case the optimum design of heat exchanger fluid configurations. So we compare between parallel to series here, we can see, and incoming fluid from the heat pump is divided into 2 and then directly entering each of the boreholes. We have 2 boreholes in the Geological Museum, while in the series and parallel is we modified the connectivity. From this evaluation, we found that the parallel series configuration has a better thermal performance, showing by the coefficient of performance here at about 0.24 COP better.
Oh, sorry, 5 minutes left.
Okay, thank you. And Oh, sorry. The next is the Chulalongkorn University of Bangkok campus. We have carried out thermal response tests in 2018, and we compare the air source heat pump system with the GSSP system in this case, and we found that we consumes in average of 28.6% less electricity compared to the air source heat pump system. In Chulalongkorn University of Saraburi campus, this is very special because we have a horizontal heat exchanger and we have two ground source heat pump systems connected to the same ground heat exchanger. One is the Japanese heat pump system. Second one is the modified system with no inverter. And we compare the electricity consumption with the normal AC with the inverter. And we found that for the hot season, we can achieve up to 18.5% electricity reduction, while for the cool season in Saraburi, we can achieve up to 40% electricity reduction compared to normal air conditioning system. But we here, because there is no inverter, we cannot achieve higher thermal performance. And we also conducted the net present value analysis for each case of the electricity reduction case compared to the air source heat pump system. And in Vietnam, this is also very special because the temperature in Hanoi allow us to conduct not only cooling but also heating for the cool season in around January. And we found that the COP is around almost 4 in case of heating, where in case of cooling, the COP is about 2.2. We also conducted thermal response tests in this field. And I would like to briefly introduce the possibility of the hybrid system using the numerical model. So this is a typical family with 2-floor house with 200 square meter footprint area. We have 6 rooms with air conditioning system connected to 9 kilowatt capacity of GSSP system. We assume the location is in Jakarta, so we use the weather data from Jakarta with the 3-layer shallow heat exchanger here in the depth of 1 meter, 1.5, and 2 meter. And we connected the ground heat exchanger with the thermal energy storage with the water supply, free water supply. And the result is, if we only use the GSSP system for 1 year run, actually we cannot get improvement in terms if we compare to the air temperature range in Jakarta. Actually, the temperature is very high after 1 year. But if we combine the system with the thermal energy storage, we can expect this kind of relationship. I mean, better thermal performance and also more energy saving here, around 17% less if we use the hybrid system. So of course, this is just the first study, so we need to do the further study. So the future work, we would like to evaluate also the long-term performance study from the installed GSP system and to evaluate the effect of rainfall on thermal performance of ground heat exchanger and more detailed study on hybrid system. For example, the thermal energy storage and water heater and other low-cost ground heat exchanger configuration, for example, open loop system or pile energy system for the new buildings. And also, we would like to expand our study to the techno-economic perspective of GSSP in application in Southeast Asia. So this is our activities in recent years. So we have lecture in Indonesia. We have discussion with the local ventures about the GSSP in Chulalongkorn University in 2017. And we also carried out workshop in Vietnam, Institute of Geoscience and Mineral Resources in 2017. And this is our concluding remarks, and we are looking forward to further cooperation with other countries as well. So thank you very much for your time.
Thank you very much for the interesting presentation. We have not too much time for question. Maybe only one question. Yes, please, Dr. Chitti.
Hi, I have a quick question.
Yes.
I believe that you probably have the ultimate goal for business model. Like, I like to know if I'm an ordinary person, I want to know what would be the best possible cost for the household if I would like to install one of these units in the house, and how long would it be, like the rate of return of the investment if I want to invest some money on the instead of air conditioning system, how long it will take before I have the rate of return of the investment. Thank you.
Okay, thank you very much. Well, this is, I think, very important considerations about the financial evaluations. Well, of course, if we talk about the vertical heat exchanger, of course, the borehole and the drilling cost is very expensive. In case of even though in Southeast Asia we estimate that the drilling cost is half of Japan, but still, I think it is very expensive to introduce this technology to the Southeast Asian countries. And one of the alternative is there are two maybe. In case of buildings, we can use the pile energy system while we are making the foundation, so we can install as well the heat exchanger. Or second kind of the possibility is the horizontal. But as we know that the horizontal is very prone to the atmospheric change of the temperature, so this is also very problematic. So one thing we should focus is actually how to increase the efficiency of the electricity reductions compared to air source heat pump system. As we can see here, for very small capacity, 4 kilowatt cooling capacity, if we achieve 40% electricity reduction, we can get payback time for 6.5. However, if we achieve less electricity reduction, of course, the payback time will become longer. And in case of 40%, I think 20 years. 20 years, maybe nobody will consider this system instead of the normal air conditioning system. So what we like to focus is actually we should think about the total thermal management in-house. For example, we are looking for where we are going to reject heat instead of the atmospheric air. That is to the ground. But we also need some kind of hot water, for example, for take a shower, for example. And we can use some kind of hybrid system, that kind of system. So maybe in the future, we would like to do this kind of innovations in the future. Maybe that's all. Maybe time is over.
Further question, sorry. Would it be possible that you use other kind of renewable energy like solar energy in cooperation with your ground source heat pump, since you want to use a different kind of energy anyway? Would that be possible?
In terms of solar energy, means solar heating or solar electricity, means solar panels. Maybe if our problem is how to, in this case, is how to reject heat, means that we have to find some reservoir that is better to receive heat other than atmospheric air, that is ground. But the problem is the longer we reject the heat, the efficiency will eventually reduce. So this is the main problem. In terms of other solar energy, of course, there is possibility. For example, if we can run the DC air conditioning, ground source heat pump system in DC, we can use directly, for example, without going through directly to the inverter, for example. I think one thing we have to highlight is there is more flexibility in the future compared to the normal air conditioning in terms of ground source heat pump system.
Thank you very much. So then
Thank you.
now it's thank you. So now let's move to the next presentation on topic of Malaysia's groundwater issue and challenges and the way forward. And this topic will be presented by Aline Clancy Mickey. He is right now the Senior Assistant Director of Geoscience Planning Unit in Department of Mineral and Geoscience, Malaysia. So please give a big applause to Mr. Aline Clancy Mickey.
Thank you, Dr. Tunasi. Very good morning, Sawadee. Greetings from Putrajaya. I'm Melvin from JMG Malaysia. First of all, I would like to thank the organizing committee for giving me the honor to present in this CCOP 2020 thematic sessions. This is indeed an honor for JMG as well for me to share some of our experience on the groundwater issue and challenges and the way forward. My presentation will be in 3 parts. My presentation in 3 parts. Firstly, and briefly on the current groundwater scenario in Malaysia, followed by the issues and challenges and the inherent problems the groundwater sector is experiencing. And finally, on the way forward towards the groundwater information transformation plan in the country. So ladies and gentlemen, for the next 15 minutes, do lend me your ears. I would like to share with you very briefly on the current scenario of groundwater in Malaysia. Ladies and gentlemen, under the National Water Resources Review, there are 4 major water resources in Malaysia, which the rainfall, surface runoff, evapotranspiration, and groundwater. If you see on the slides, we have a big potential groundwater reserve, which is around about 5 trillion meter cubic yet to be explored for the water supply. Just how much is that? It is equivalent to 160 times of the volume water held by our 90 lakes and reservoir, and 9 times of total volume water that annually flows to our rivers. From the screen, we can see the estimated safe yield of groundwater extractions for Peninsular Malaysia is around 27,000 mld, Sabah around 19,000 mld, and Sarawak around 41,000 mld, giving the total of 87,000 mld. But we can clearly see that the overall yearly extraction of groundwater stands at no more than 260 mld. This is equivalent to 0.0028% of that. And as far as the usage of the groundwater per use in our national water utilizations, it is still very low, as can be seen in the next slide. From the slide, you can see our raw water supply in Malaysia comes from surface water, whereby 18.2% comes from the dams and reservoir, while the remaining 80.5% comes from the rivers. Only 1.3% of the raw water supply in Malaysia comes from the groundwater. In terms of groundwater usage, despite having vast amount of groundwater, Malaysia is still lagging behind compared to other countries such as Denmark and Australia. There are actually many agencies, both federal and state, as well as those from private sectors, that have been constructing tube wells. This include Department of Mineral and Geoscience, or JMG. We have been actively involved in explorations and development of groundwater resource in the rural and urban areas. Through our expertise in the field of hydrogeology, JMG has been developing tube wells in fulfilling our social obligations, supplying alternative clean water in water-stressed areas and rural areas. For example, to the villages, it has been made possible through our innovations and constructing a simple groundwater treatment supply system known as SPATA, which reduced the content of manganese and ferrum to a more personable level for domestic purpose. As shown on the screen, to date, since the 5th Malaysian Development Plan in 1986, JMJ has contracted around 4,800 tube wells, with a total project cost amounting to 176.7 million, which benefit around 1.5 million people nationwide. If we look at the If you look at the breakdown of the family system, sense of the use of domestic purpose, and followed by both factories and agriculture at 21%, followed by the construction at 4%, pit fire control at 3%, and mining at 1%. Ours is not the water scarcity. In some countries in the world, we in fact have there are obviously several water-related problems, which has forced us to think more about the possible use of groundwater in our utilization structure. Firstly, we have problems for not managing the water resources effectively. Traditionally, we have been too dependent on surface water supply for domestic, irrigation, and industrial needs. This has caused imbalance in the water drought and prolonged plenty water during monsoon has often led to the flooding. More often than not, people may think of groundwater when there's no water during the drought season. At the same time, pollution of our water costs have impacted the aquatic ecosystem. Some rivers are now so badly polluted that for practical purpose, they are
sorry, I cannot hear your voice. Yes.
Can you hear me now?
Maybe internet connection is not good.
Yeah, can you hear me now?
Yes.
Okay.
Okay.
Okay. Sorry. So, if we continue to adopt this business as usual practice, the country will face an even more serious problem, especially when coupled with a fast-growing population as well as rapid urbanization and industrialization. Ladies and gentlemen, there are basically three main factors which is prohibiting the development of groundwater in Indonesia, namely limitations and fragmented tools. The first factor is due to enabling constraint with respect to water. The federal constitutions give the federal and state governments certain powers. The federal government has powers over shared rivers, federal projects,
Alvin, your sound is on and off.
I think the internet here, I guess. Is it? Can you hear me now? Can you hear me now? Can you hear me now?
Yes.
Alright. Okay. The federal laws, which include the Geological Survey Act, which enable collection of data and monitoring exploration. Environmental Quality Act, which empowers monitoring of water quality and reliability of groundwater. Town Country Planning Act for land use, and distribution of treated water. However, for the bottled water,
Alvin, I think we are losing your voice, so I think we recommend that you turn off your camera.
Yeah.
Maybe the sound will get through better.
Okay. Is now okay? Can I continue?
Okay.
In the recent time, JMG has established itself as an expert organization for matters related to the groundwater in general. This mandate, however, is limited to exploration and development work. We are not empowered to issue concession licenses, this being the prerogative of the state in which the aquifer is located. As for the state government, we have full jurisdictions and responsible for natural resources. This includes water. In the recent years, some state government have enacted specific law in relation to water resource management.
Now we're losing you.
I'm sorry, because I think the internet here. Is it? May I continue?
Okay.
Maybe can you come closer to the microphone?
Sorry?
Closer to the microphone.
Actually, I'm very close to the microphone now.
Okay, go ahead.
My mouth is actually next to the microphone.
Okay.
I believe this is the internet connection. Okay. All right. Where are we? Okay, for the second factor, due to limitation of funds, seems to be overly reliance of the government financial budget, usually the development budget. And for and then also there's a lack of latest technologies and human capital investment for the industry and stakeholders. We are still lagging behind in terms of technology. Other countries have gone further forward to leaps and bounds. Our people needs to be exposed in these latest technologies. The third factor of the groundwater management tools are fragmented. This is due to the lack of systematic monitoring of risk communication and evaluation framework on the groundwater issues. There is a lack of data inventory of groundwater and insufficient groundwater inventory database. There are also lack of infrastructure of R&D and C on the groundwater potential evaluations for development management and risk assessment, as well as insufficient local expert and enforcement personnel to regulate and manage the groundwater resources effectively. Apart from the issues and challenges mentioned, the groundwater industry also faces two major inherent problems, which is the public or stakeholders' perceptions, as well as on the human capital development. Public perceptions towards groundwater may range from very to downright hostile. Main perceptions is that groundwater is a limited resources, is unreliable, is polluted, is expensive to develop and maintain, and also have negative impacts on the environment. This is crucial need to change these perceptions, which is totally not right. There is a failure by the public and even from the water sector itself who failed to recognize the potential of groundwater resources. There is a misconceptions on the groundwater exploitations. There are people who believe that groundwater should be left intact. But one thing for sure, there is very low public awareness and acceptance on the groundwater. The other inherent problem is regards to the groundwater development on the human capital development which regards to producing groundwater experts. This is due to the present fragmented and unstructured capacity building, ineffective human capital development blueprint or program to ensure the producing local experts continuously. For example, the professional drillers, modelers, professional hydrogeologists and water engineers, insufficient fund for training, short course, seminars and conference, and also industry overlay reliance on government incentive on human capital investment, which lead to slow growth on groundwater SMEs. What is the way forward for groundwater development? JMG identified three main sectors that need to be improved as part of our way forward, which is the smart partnership, enabling instrument, management tools. In smart partnership, we need to create more smart partnership and collaborate proactively in groundwater user in the developed countries. As a start, JMG is in the midst of looking any possible international collaborations for technology transfer or fund sharing projects. Not forgetting our very own stakeholders, there is also a need to work closely with them to ensure, educate, and save water for all in line with the Malaysian water vision through smart partnership. As mentioned before, we need to formulate the groundwater policy to strengthen the national water resource policy, at the same time promote code of practice for groundwater management. Subsequently, by introducing the new Geological Survey Geoscience Act, this is enable us to govern and manage the groundwater industry better and effectively. It is useless to have a best enabling instrument system with outdated management tools. We need to upgrade the current groundwater database for big data analysis in the national level. This is in line with the current industrial revolutions, IR 4.0 trend that the world revolving now. Lastly, we need to do rapid groundwater mapping in the national.
Sorry, 2 minutes left.
Ladies and gentlemen, for the past 15 minutes, I've discussed the issues and challenges for the groundwater with all of you, and also outlined few initiatives that needs to be done towards the improvement of groundwater governance and development in this country. To conclude, the strategic move is essential to mainstream groundwater usage for water security and economic growth. This is important as our government has initiated to mainstream groundwater usage by 20% by 2030. Therefore, the effort in having an integrated water resources management through promoting and mainstreaming groundwater usage The water sector, conjunctively, is in line with the 2030 Sustainable Development Goal (SDG) agenda in addressing the rapid growing demand for the water and threats for the water security. Ladies and gentlemen, with that note, I thank you.
Thank you very much for the presentation. Any question from the audience? Okay. Dr. Lee has one question.
Arvin, good morning. Thank you very much for your nice presentation and very complete information on the groundwater status of the Malaysia. Actually, as you remember, I was invited previous years, 2019, for the international workshop, which is convened by the JMG in Kuala Lumpur. At the time, I was very surprised to know that you have very ambitious program on groundwater. Even as far as I understand, relatively compared to other CCOP member countries, Malaysia is not a very water in terms of water security is a very stable status. But even the situation, even your minister and then your JMG has a very good ambition and then program to promote groundwater. It is, I was very impressed by your programs at the time. So I actually do not have some very special questions, but I really hope that your program, as you shown by your presentation, to be continued, and then some collaboration with other member countries with the CCOP could be more helpful to complete your program in the near future. Thank you.
Thank you.
No question anymore? Okay. Thank you very much, Alvin. Okay.
Okay, this is my turn. Okay, next paper will be given by Miss Chadapong Busaka from DJR. The title of her paper is Characterization of Contaminated Groundwater and Remediation Plans in Nampu and Rangbo Subdistrict, Ratchaburi, Thailand. If you're ready, please go ahead.
Thank you, Dr. Doshia. Good morning, everyone. So my presentation will be related to groundwater quality in the topic of characterization of contaminated groundwater and remediation plans in Nampu and Rangwa subdistrict, which is in Ratchaburi province, in Thailand. So here's my outline presentation. I'll start with the study area and the background, and then the objectives, then the methodology and the results of our project, and then introducing the remediation plans. So this is the map showing the study area of our project. The site area is former industrial waste recycle company in this white border, and which is located in Ratchaburi province, about 3 hours drive next to Bangkok, Thailand. And this study area cover about 5 square kilometers. So this industrial waste recycle company, or the landfill site, is located here in the plain of Thalu Hill. So this is the mountain, big mountain on the east side, and there is the main stream called Nampu that flow from north to southeast of the area. The elevation of this area varies from 80 to 100 meters above mean sea level. So land use near this site include the agricultural area, which is the villager will do farming and for sugarcane and tapioca field. And there is the limestone mine in this area and one pig farm in the south. So I'll talk about backgrounds of this project. So at the former industrial waste recycle company or landfill site, volatile organic compounds and some heavy metals were found in shallow groundwater. So in 2014, the results of site investigation conducted by Department of Groundwater Resources and Pollution Control Department reported that VOC and nickel concentration in groundwater in monitoring wells and villages were found at higher than standards. And then we have been monitoring in 2015 to 2017. There still be the presence of cis-1,2 dichloroethylene, trichloroethylene, benzene, and vinyl chloride, and manganese and nickel in the area. So in 2018, vinyl chloride concentration increased up to 461 microgram per liter, which is found in the monitoring well in landfill site. So we need the precise information of the site characteristics and effective remediation plans for treating polluted groundwater. In April 2020, this year, we started conducting the project. The objectives of this project is to identify the presence of characteristics of contaminants in the subsurface and to propose potential remediation plans and provide guidance for a community and environmental agencies in terms of groundwater management in contaminated areas. So here is the result. And so first of all, we conducted field investigation, which consists of geology, hydrogeology, and geophysical survey. This is the map showing the geological map of the area. So there are two main rock units, which is quaternary unconsolidated sediment composed of sandy clay, gravel, and rock fragments. And another big bedrock is Permo-Carboniferous, composed of meta-sandstone, mudstone, siltstone, quartzite, and dolomitic limestone on this talud hill. And this is the example of the result from 2D resistivity method. So we can divide it to 3 layers of the resistivity value. So the first layer for low resistivity composed of wet soil, clay, which is the shallow aquifer. And the second layer is moderate resistivity value, about 25 to 300 ohm meter. It composed of weather rock and dry silty clay at the depth of 15 to 45 meter below the ground. And the third layer, which with the high resistivity, about 200 to 2000 ohm meter, composed of bedrock at 30 meter or deeper. According to the geology information, borehole drilling data, groundwater level measurement, we can identify hydrogeological setting for this area. So the map on the left showing the aquifer units of the area. And then we have the cross-section lines showing here. And for the right map is the groundwater flow direction. So groundwater flow seems to follow the topography, which is the flow from high plain on the northwest to lower plain of the stream to southeast of the area. And here is the first hydrogeological cross-section from west to east line, which is the line showing here. So So there are 5 different layers of soil that you can see in this cross section. So this pink layer is the thick clay, which is up to 8 meters thick, and underlain by this layer, which is weather rock. And next to the weather rock is the bedrock. So there are 2 types of aquifer here, which is unconfined aquifer composed of sandy, clay, silty sand in this layer. The depth of water is 1 to 6 meters below the ground. And confined aquifer, which composed of massive limestone, meta sandstone, mudstone, which is 20 to 80 meters below surface. And another cross-section line is north to south, which is showing about the similar characteristic. And from all of the data, we used hydrogeoanalysis software to create this fence diagram to be quick understanding the hydrological model of this area. And another tool that we use to investigate the site is the direct push method logging tools. We call it membrane interface probe and hydraulic profiling tool, or MIHPT. So the probe is look like this in the picture. The principle of the operation is while we drill into the soil, there is the heater block in the probe that will heat up the soil and up to 120 degrees Celsius. Then the VOC in soil will turn to gas, and then the carrier gas in the probe will lead the VOC up to the surface to the detector in on the ground. So we have 3 detectors in this equipment. The first one is photoionization detector, or PID, which will respond to aromatic hydrocarbon. Second one is halogen specific detector, or XSD, will respond to halogenate compounds such as the chlorinated solvents or vinyl chloride. And the last one is flame ionization detector, or FID, will respond to stretch or branch chain of hydrocarbon like butane, methane. And here is the result of 100 drilling locations with the area of high response to each detector shown in this map. So we know that which area have the contaminated on this VOC type.
5 minutes.
Okay, thanks. Okay, to study the fate of pollutants, we install new 20 monitoring wells across the study area with the depth of 8 to 19 meters. And we also do the soil core sampling using direct push to analyze for soil quality. And also collect the water samples from the well and from monitoring well. So then we know that contaminants of concern, there are nickel, manganese, and also vinyl chloride, benzene, and this one too, dichloethylene. So here is the result of the analysis of nickel. As you can see that the red dots are the nickel concentration that higher than pollution control department's and standard. And for benzene concentration showing in this map. And the contaminant will be in the landfill site here. And the last one is vinyl chloride concentration. That we can see that it's even higher than the Department of Industrial Work standard, which is 30 microgram per liter in the purple dots. So for the remediation plans, we have come up with 2 plans with the point source remediation, or we will try to design and construct the permeable reactive membrane. And for the villagers well, we would use the groundwater treatment for drinking water, which the possible is to be nanofiltration system. To conclude this project, so the thing that we already did is the residents should be warned not to use groundwater from contaminated wells, and we should provide the clean water sources for domestic use, and have to treat contaminated groundwater and soil with effective methods, and then plug the wells that install well screen in contaminated aquifer to prevent the expansion of contaminated water. And lastly, remove source of contamination or source control. Thank you.
Thank you very much. A wonderful talk and the very detailed survey result of the site in Thailand. Okay, any question or comment from audience, please?
Good morning. Can I have a quick question, please? You mentioned about start to detect the contamination in 2014. Can you give us a little more history about the establishment of the company, the waste treatment company? How long has it been there?
So this company they'll collect the industrial waste from, I don't know the source, so from industrial sites, and then they have recycling factory inside. It's probably start 20 years ago. I'm not sure about the year. Yeah.
Can I, in line with this question, actually, it's quite clear that all the VOCs and then some heavy metals comes from that company.
Yes, because we based on the data, analytical data, and the groundwater flow direction.
So in the case, by the law, maybe in Thai law, the company have some penalties, or maybe what is the result after you found out that kind of contamination caused by the company?
So based by the law, this company has to be shut down. So they already shut down this company, and now they are trying to what to say? Yeah, and we have to monitor and try to come up with the remediation plans. Yeah, since it's already contaminated.
A quick question. I have done this work before a few years ago, but we have not got new equipment or technology. Right now, I saw at the last map, they have highest. Let you show the last one. I saw it's 2,170 ppm. I would like to ask you, how do you think about this? Why it has higher than the other point at the dumping site area? What is happening?
This is the observation well near the landfill. This point. Oh. Hang on. For vinyl chloride, yes. So it found in this well. So I think so. We collect the sample in dry season, and then I think it's because of the what is called in dry season. So it less dilution and and then that we assume that the hotspot should be near this well.
And did you do the
MIP
soil sample in that area, or they have anything in the ground?
So we collect soil sample here Yeah, near that well, but we can the detector responds to VOC in the soil in this site. Yes, just VOC, but in soil analysis, the VOC and petroleum hydrocarbon is not detected from the laboratory.
What do you think? What's happened? Why it have so just only have vinyl chloride, but the other element no found in this point.
Oh, I mean this point it found another VOC types, vinyl chloride, benzene, and trichloroethylene, and nickel. Yeah.
Sorry, I think we should move on. If you have more questions, please use the chat or email afterwards. And thank you very much for the wonderful talk. And we move on.
Thank you.
All right. Next paper is from China. The title of the paper is Cycle Performance Investigation in Compressed Air Energy Storage in Aquifers. Author Li Chaoyang and Professor He-Chin Chen. The author ready to present?
I think he's not in Uchida-san because I cannot find in the participants.
Okay, maybe skip it. So okay, let's go to the next paper. The next one, the title of the paper is GSI Field Data Capture Application using OGC Web Services and Spatial Data Infrastructure Model for efficient processing and sharing of field data, given by Joel Bandibas and Shinji Takaraza. The presenter is Joel, and if you're ready, please go ahead.
Joel-san, can you turn on your camera? Okay. Okay.
So the objective of our study is to develop a simple and cost-effective mobile application for gathering and sharing field data, and to use GSI as the platform for sharing real-time field data. So this is the outline of my presentation. First, I'll be giving a brief introduction about the GSI project, standards used by GSI, the different web services and data models, and some applications being developed using the GSI's web services and geospatial contents. Then the last part is the field data capture application of GSI. So first, this is our GSI project. This is implemented to develop a new geoinformation integration and sharing system using international standards and free and open source software among the CCOP member countries. So these are the different countries participating in this project. And these are the major information being shared by the information system. So GSI is WebGIS, and in this kind of system, we have two major components. We have the clients and the server. The server part is where the GIS software and the database are located. So this is a more detailed scheme of the information system. As you can see in the internet side, you have a distributed database, and at the same time, you have the GIS software running under different operating system and different kinds of GIS softwares. And on the client side, we have a wide array of devices and softwares also, so that for this information system to work, we have to accomplish interoperability. To do this, we have to follow some standards. And for the GSI system, we have two major standards used: the Spatial Data Infrastructure and the Open Geospatial Consortium Standard, or OGC. So for the SDI, we have here the scheme of the SDI. It is a three-layered model. The upper part is the application. The middle part is the geospatial services. And the bottom part is the database or the geospatial content. So users, applications interact with the services to get information on the geospatial content, the database. So it is in the middle layer where the OGC web services are located. So about the OGC, it is the Open Geospatial Consortium. It is the grouping of companies, government agencies, and universities that set the interfaces and encoding standards so that the general public or developers can develop applications that are interoperable. And these are some of the popular softwares that are OGC compliant. So we have two major web services used in JSI. We have the web map service and the web processing service. For the web map service, it provides a simple HTTP interface for requesting geo-registered map images from one or more distributed geospatial databases. So this is the scheme of the WMS. We have here the client and the server. So if you want to display a map online, you have to send a request to the WMS software, and this software will query the database and return the result as map images. So this is an example of a get map request. This is the red colored part is the URL, and the parameters are these, so that if you point your browser to this site, you can have these results. So you are displaying the active fault map of East Asia using WMS. For the WPS, similar to WMS, but in this case, you send a request, the software will query the database, and it will return a result in the form of JSON, JavaScript object notation, or an XML format, which means software can parse and display the result in understandable form. So this is an example of a WPS. This is the script to query the database to determine the nearest active fault from the user's location. So this is now the information being parsed and displayed as pop-up on the screen. So this is the scheme of the GSI spatial data infrastructure. We have here the data owners, which are the different countries participating in the project. So the data owners should formulate the web services and populate the database to share their data. So we have here applications, desktop clients, you have the GSI main portal, we have the GSI mobile, and the GSI generative WebJS portals. The bottom layer is, of course, the database, and we have here the web services at the middle. So this is the GSI main portal. You can see the different flags of the countries, CCOP member countries that are participating in this project. So these buttons, you can click this button to view the GSI generated WebJS portal for each country. We also have here featured GSI thematic portals. For example, we have ASEAN Mineral Resources, Asia Pacific Region, Geological Hazard, and so on and so forth. So this is the information categories hierarchy of GSI. Well, the topmost is the GIS portal. Then it is this portal has catalogs registered to it. And then we have the map layers, database, users group, and users. In a GSI system, the data owners in this hierarchy of information can decide the access privilege of the users of the information. So access privileges range from 0, no write, to 7, unlimited write. You can download, display, and edit the data. So these are the different access privileges in GSI. And this is the summary of the GSI data model. So this is one of the GSI generated thematic portal. This is the Asia Pacific Region Geological Hazards Information System. So this site provides information about earthquake, volcanic activities, tsunami, and so on and so forth. And presently, this site is monitoring in real time the seismic activity worldwide. And this is another GSI generated site. This is the ASEAN Mineral Resources Information System. So this is currently operating. You can visit the site if you want. And here is our mobile application. So the GSI FDC, field data capture application, formulates two WPS. First is the WPS for formulating web services, and the WPS for inputting field data into the database. So the web services will access the information being stored in the database, and the clients can access that information generated by the mobile application. So this is a very simple application. So in the GSI FDC, we have three hierarchy of data. The uppermost is the event. So if you decide to gather information about an event, it is the occurrence of a phenomenon. One event corresponds to one map layer in a GSI system. For example, your event is the earthquake in, say, Manila. So you can call it as Manila earthquake, for example. And the sites are locations where information are gathered about the event. So each location is defined by a geographic coordinate, location, name, and description. And the sites are map layer points in the GSI system. And we have here pictures, and later version we have videos, are images taken in sites providing additional information about the occurrence of the event. Pictures are displayed on picture information pop-ups in the GSI system. So this is the main page of the GSI. So it is very simple. Either you log in, then you view the recorded events, or you create an event, just have event title and the description. And then you can populate the event with lots of points. This is an example of event point. In this case, this is the damage survey conducted to determine the damage caused by Typhoon Ulysses in the Philippines. So this is a portion of Luzon that was flooded during the typhoon. And this is another point of Ulysses typhoon event. It is in another picture of the flooded area. So as I mentioned earlier, one event is a layer in GSI. So this is one layer you can see in the GSI system. This is real time. If you create an event, it is immediately reflected in the GSI system. So we have 2 points here. And if you click one of these points, you can have this is in Metro Manila. So this is one site. This is Provident Village in Marikina City in Metro Manila, where it was flooded. So this is a big river here. So you can zoom the picture, of course, to have more information. And this is the flooded area in northern Luzon. So this is an aerial view of the area. So of course you can also view the site in detail. So later, as I mentioned, we can have also video. And of course, this application is very useful for geological field surveys. So this is an example of gathering geological information of an area. So this is the event name is Ibaraki Field Survey. This was 2 years ago, I think. So this is the point here, and you can see the details of the geology by providing more pictures. So you can add as many pictures as you wish, you want. And this is the current CCOP Thematic Session 2020. So this is what we are doing presently, and this is our room here in GSJ. So this is the building, and this is the Geological Survey of Japan building, and the room where we are presently here, presently staying. So to summarize, the GSI field data capture application provides data that can be shared in real time on the GSI portal and its generated websites. The application is an efficient and cost-effective system for sharing data on natural disasters and field surveys. Thank you.
Thank you very much, Joel. Okay, a question or comment, please, on the floor. Please go ahead.
How about the security issues, Joel-san? Can you assure the security? The privacy of the people or the around the area where you are putting the pictures.
So of course,
no provision.
So of course we can decide about the privacy level of that event or what we call layer in the GSI system. So for sure, we will be very careful about that issue.
Can I?
Please.
Okay, thank you very much for your nice presentation about the field data capturing system. And then the GIS project is, as I already mentioned, one of the very important and legacy project in CCOP, I believe, because it is quite related to the digital transformation, which is a very important issue at the moment. So I really appreciate that contribution of this Jay for this project and then one short comment for you is this very big, very nice program to having some picture, the capture the picture, but is there any possibility to in line with the AI technology to identify some rocks or some geological structures to be added this program, which is more helpful and more complete to make your system? Thank you.
Yeah, thank you very much for the question. I think the general direction for this information system to be more useful is to apply this kind of technology. And presently for classifying geological sites, we have currently this what we call satellite image classification. You can do this automated identification of areas for a particular geological form. There are lots of researches for that. So this kind of thing we can incorporate into the GSI system. So currently we have this Aster data WPS. So maybe we can add this kind of functionality in the GSI system.
Okay, thank you very much for Joel. And we should move on. And let's give a hand to Joel. Thank you very much. Marvik, can you listen to me at this setting?
Yes.
How about the screen now?
And it's okay. You can put the slideshow.
Pause? Okay.
Please put the slideshow.
Yeah, it's slideshow. But if not, we like this.
Okay.
All right. Next paper is the title is Publication of Revised Political Memory Map of Eastern South Asia by Dr. Takemi Chara and myself. And Chara-san is many experience geophysics and observed for CCOP many times. Yeah. Chara-san, go ahead.
Oh. Good morning and good afternoon.
Yes, good day.
I am Takemi Ishihara from Geological Survey of Japan, and I borrow Uchida-san's PC to make PowerPoint presentation. So the title of my talk is Publication of Revised Magnetic Anomaly Map of East and Southeast Asia. And I was coordinator of CCOP aeromagnetic map compilation program. And as the product of this project, we published 2 sheets of magnetic anomaly map. The upper one and lower one, 2 sheets. And it's CD-ROM versions. However, there are many data gaps in the map. So a new CCOP GSJ MAMEA project, which means compilation and publication of a revised magnetic anomaly map of East Asia at the 1 to 4 million scale, has been carried out since 2016 with the aim to create a revised map with new data contribution from CCOP member countries and new marine data available now. So I'm again a coordinator of MAMEA project, and the compilation, particularly preparation of new data, was carried out in close cooperation of the contacted persons. This shows the spatial data distribution for the old map. By the way, the longitudinal limits and latitudinal limits are same for the new map.
Excuse me, Ishihara-san.
Yeah.
We can only see the first slide.
Oh, really?
Of your PowerPoint. Only the title, so I'm not sure. Oh, now it's okay.
Okay.
Can you see the survey lines for 2002 magnetic map?
Yes, we can see now.
Yeah.
Yes, you have to change the mode to slideshow.
And slideshow?
Slideshow doesn't work, so please use it.
Yes, so anyway, many CCOP countries, member countries and cooperating countries contributed to this old magnetic map. And Philippine data P1 was not included in the CD-ROM of this old map. And this shows the data distribution of for a new magnetic map. New data or revised data from Cambodia, Japan, Korea, Malaysia, Myanmar, Papua New Guinea, and Philippines, and USA. We found ground survey data in Taiwan, and there are many marine data collected by more than 800 cruises of various institutions. And this shows the information on the data used in the new map. These are old data sets, and these are new or revised data sets. The survey altitude variable. And the processing of the collected data have been carried out as follows. First, adjustment of average value between different data sets, gridding, and upward continuation. We adopted 2 minutes of arc as a grid size, and an altitude of 1,500 meters above ground for land area. And so the debel data collected by airplane at constant altitude above sea, and drape data at constant altitude above ground, both of them are upward continue to draped surface at an altitude of 1,500 meters above ground for land areas. And no continuation was applied to offshore data. And the product of MAMEA project, we made magnetic anomaly map of East and Southeast Asia for the whole area of longitude 93 degrees to 160 degrees east, and latitude 12 degrees south to 46 degrees north. Additionally, we made 3 detailed maps for Thailand, Malaysia area, Philippines, and Papua New Guinea areas. And the whole area map was created using 2 minutes grid data at an altitude 1,500 meters above ground for land and 0 meter for offshore areas. And while the detailed maps are created using 1 minute grid data at an altitude of 300 meters or 1,000 meters above ground for land area and 0 meter for offshore areas. You can download the files of explanatory note for magnetic anomaly maps, one for area and the other 3 for detailed map areas in JPEG format, and the corresponding 4 grid data with format longitude, latitude, magnetic anomaly, or altitude, additionally altitude. From the website of GSJ and CCOP. This is the whole area map created by 2 minute grid data. You can enlarge if you want to see parts in more detail. We try to fill data gaps as much as possible, but there are many, some areas remain blank. And these are detailed maps created by 1 minute grid data. Thailand, Malaysia area, Philippines, Papua New Guinea areas. This one and this one at an altitude 300 meters above ground. This one at an altitude 1,000 meters above ground. This is the comparison between detailed map created by 1 minute grid and 300 meters above ground, and the one extracted from the 2 minute whole area map, 1,500 meters above ground. You can see the short wavelengths variations in the left map are smoothed out in the right one.
5 minutes left.
Yep. I made these maps using GMT software, and I'd like to show a simple shell script to make smaller areas. This one for landscape figures and almost similar shell script for portrait figures. So this is an example for sorry. This one for landscape map. We specify left and right or west and east longitude limits and south and north latitude limit and title. And we can get landscape figure like this. We can see very clearly magnetic anomalies due to seafloor spreading in the South China Sea. And I think this one is probably the magnetic negative anomalies due to Kontum Massif in Vietnam. So this is another example for portrait figures. Similarly, we specify the longitude and latitude limits and name. There is a international compilation project for the whole world, World Digital Magnetic Anomaly Map, or WDMAM. And our old data was used in current version of WDMAM. And our new map will contribute to the next version of WDMAM. So in conclusion, a revised magnetic anomaly map of East and Southeast Asia has been successfully compiled and will be published online soon. You can download from this GSJ's website and CCOP website. And this map will give valuable information for reliable regional geological interpretation in CCOP countries. And we look forward to additional data update in the future. I would like to take this opportunity to thank contact persons for the project and CCOP Technical Secretariat and other data contributors. Thank you very much.
Thank you very much, Ishira-san. And we are sorry about the inconvenience of this PC problem from Japan. Okay, any question and comment, please?
If no, can I just quick comment? Actually, I really appreciate all the effort. Actually, I think this is really a very nice masterpiece of the collaboration between CCOP and then member countries and Geological Survey of Japan. So I really appreciate all the dedications, especially from the Takemi Ishihara-san and then Toshi together, and then all the ESJ person. So I really believe that I would like to please give them a big hand for their big contribution. Thank you. Thank you very much.
Thank you very much.
Can I have a quick question?
Yes, please, Didi.
Yes, yes. Very nice talk, Professor Ishihara. Thank you very much. I'm wondering it used to be a gravity data set created by GTEC and CCOP, I believe. And normally, if we study magnetic data, we normally compare with the gravity data as well. It's going to give you a very good, how do you call it, comparison, and also review a lot of subsurface data information, geological information. So would it be possible, my question would be, would it be possible that you cover the gravity data as well for the region and create another set to be comparable to the magnetic data?
I think, well, I think China is now carried out project on the gravity data compilation. So we would like, I'm very glad to send these data to China or any other countries. And if you have any assistance or cooperation from Japan, I think we could do that. Yeah.
I think we should talk with China about their IGGP2 project on the gravity compilation, because we started together, and it's good to collaborate for both magnetic and gravity data for sharing. Okay, any other question? I'm sorry that the chair. Oh, okay. Go ahead.
Just a quick question. Actually, comment. Would it be possible to download this kind of data now?
No, I'm sorry, but I think this month, by the end of this month, it's ready for downloading.
We are at the final moment for approval in our institute, so please wait for a moment. Okay, I think it's time, and I'm sorry that we run over the time. And please join me to give a big hand to all presenters this time. Thank you very much. And give hand to the
Thank you, nice chairperson. Thank you.
Yes, thank you very much. Thank you, our chairpersons, Dr. Toshihiro Yoshida from Geological Survey of Japan, and also Dr. Manusawi Heng Suwan from the Royal Department of Groundwater Resources, Thailand, for your excellent services. So now we break for lunch. We are a little bit behind the schedule, so like 10 minutes late or something. But anyway, we try to show the video of the poster presentations. Can we show it right away? I don't know. Maybe we just play the video during the lunchtime, and also you can go and have some lunch, or if you have some sandwich and coffee. So that'd be nice if you be sitting in front of the computer and watching the video at the same time. And for now, we are going to break for lunch, and then we're back to the last session at 1 o'clock Bangkok time sharp. Thank you very much for your cooperation here.
Hello everyone. Today I would like to talk about metallogeny and metallogenic map of the southernmost part of Thailand, which is the research done by Chulalongkorn University and Department of Mineral Resources. And this is the roadmap of my talk, starting with introduction, materials and method, result and interpretation, and then end up with the discussion. This is the previous metallogenic map of Thailand as published by Department of Mineral Resources about 2 decades ago. If you look here, nothing much. This is the southernmost part of Thailand, which include Yala, Patalin, Narathiwat provinces. Nothing concerned at all in the previous map, particularly for the metallogenic data. So our objective here is to collect mineral deposit and geologic data, as well as to construct a new metallogenic map of the study area. In order to do that, we need to get the literature reviews, and then following by airborne geophysical data, remote sensing data, and more updated mineral deposit, as well as petrochemical, geochronological, and tectonic map of the country. The tectonic map that we use is follow myself, which has been done long time ago in 2002, and the result at that time mentioned about Pattani suture, which is the northward extension from Bentong Luop suture zone in Malaysia. And if we look carefully for the Bukit Cavity, some contrast between something which is to the west and something which is to the east of the red color zone, which I call here as Pattani suture. And this is the radiometric map or ternary map, which consists within the suture of the low magnetic anomaly, and the residual field magnetic anomaly here doesn't feel clear in this picture. So I use the geologic map, which is done by Department of Mineral Resources, and this is the more clear of the Narathiwat province, which indicate there are some difference between planetoid to the west and planetoid to the east of the suture, which is red color. The suture itself is more or less the ophiolite sequence, but the granitoid occur as a result of the subduction to the in terms of the I-type granitoid and the partial melting of the meta-sediment in terms of the S-type granitoid to the west. And this is the a kind of metallogenic belt which is located in Chantai to the west of the suture, and to the east of the suture is the metallogenic belt for the Indochina terrain. These two sutures is quite clear in terms of the mineral deposit as well. If we take a look at the suture right over here to the west, it consists of the three tin, tungsten and rare earth belt, which is equivalent to Malaysia side, is called the West Tin Granite. In the middle, which is the red color for Thailand, but in the middle for Malaysia is the gold belt, which shown here as a yellow color. The gold occurrence in Thailand and Malaysia. In Malaysia, it's clear that it's mesothermal lode gold deposit, but in Thailand, it's clearly only the lode gold deposit occur just only one spot within the suture zone. And right here is the chromite. In Thailand, there is one chromite which belong to the ocean floor stratigraphy, but in Malaysia, all the same, there are chromite deposits, particularly the southern part of the Bentong Luop suture. And again, manganese deposit within the suture zone. Also in Thailand, we still have the same thing. So in this case, it would like to mention that there might be some kind of the cooperation between Thailand and Malaysia. Only in Malaysia we have the very good detailed geology, and they start to have metallogenic map. So in Thailand, we probably do the same thing, and that's all of my talk. And I have to acknowledge these people and also Chulalongkorn University and Department of Mineral Resources.
Good morning from Thailand, everyone. My name is Papawadi Otalawana. I am working at the Department of Groundwater Resources. Today, I would like to present my poster. The title is Integrated Water Resources Management, IWRM, due to climate change in Thailand. The first topic is introduction. As everyone knows, how water resources are important for our daily life and human activities. It becomes increasingly important as the agricultural industry grows and the demand of water increases. Climate change causes repeated drought and flood every year in many areas in Thailand. It has a direct effect on changes in water level and water volume on both surface water and groundwater. The Department of Groundwater Resources (DGR) is the main agency that oversees and manages groundwater resources throughout the country. DGR also has direct responsibility for groundwater resources research as well as the exploration and assessment of groundwater potential, conservation and restoration of groundwater resources, and the control of groundwater applications for essential business operations. Integrated water resources management is essential for implementing a sustainable system of water use in the country. Next topic is methodology. Recently, DGR has managed many groundwater management projects to address the recurring problems of drought and flooding every year. For example, the project of artificial shallow groundwater recharge and recovery throughout the country, or we call ASR. As you can see in the photo, it can store large amounts of water, of groundwater flow to aquifers in the rainy season, and the groundwater will be abstracted from aquifers to be used during the dry season. In addition, groundwater is also used for agriculture during and development of groundwater in the area as riverbank infiltration or RBF. It has two types of wells. The first one is vertical wells and the second is horizontal well. Right now, DGR have set up the vertical wells. Next time, DGR will try to set up the horizontal wells. The study of development of large groundwater sources, remote transmission of groundwater to solve drought in water-scarce areas. As you can see the big tanks, there are 4 large steel for store a large amount of groundwater, around 150 cubic meter, along with a high tank is for maintaining and keeping stable pressure around 300 cubic meter to pump and distribute groundwater for local people in that area. Groundwater development is not only to support agriculture consumption by using solar energy technology, but also to enhance community water security. Transboundary aquifers management with neighboring countries plays an essential role that is indispensable for integrated water resources management as well. Furthermore, the participation of all stakeholders in water management, especially water user groups such as farmers and villagers, requires a network of local water users as well as laws enforcement to regulate the use of groundwater. Integrated water resources management in Thailand is a cooperative concept to work in many Thai government agencies such as DGR, the Office of the National Water Resources, the Department of Water Resources, the Royal Irrigation Department, also the Department of Mineral Resources. DGR has so many projects to develop groundwater resources. The main aim is to sustain water resources development, both quality and quantity, for our future generation. The last topic is conclusion. Climate change affects water bodies that are in the state of drought and floods every year. Water resources should be managed, well planned and utilized for all benefits. Therefore, integrated water resources management is one of the key concepts of socio-economic benefits for the water use sector in terms of food production, drinking water, jobs, other recreational activities with participation of all sectors. It is necessary to move forward together with government agencies to sustain water resources development for the future generations. Thank you for your attention.
Hi everyone, my name is Sunista Jansom. I'm from Department of Geology, Chulalongkorn University, Thailand. So I am pleased to be here today to talk to you about for displacement accommodation and slip fish in the Mae Hong Son Fault, northern Thailand, and integrated investigation at Metalut site with 3D trench modeling. The Mae Hong Son Fault is a north-south trending active fault in northern Thailand, which produces mostly very minor earthquake magnitude in the Mae Hong Son and Tak area. However, the largest earthquake ever recorded was a magnitude of 5.6, happened in 1975 at Bat Tha Song Yang, Tak province, the southern of the Mae Hong Son province. However, the Mae Hong Son Fault consists of 55 segments. Based on our interpretation from remote sensing data, among these segments, the Metalut Fault segment, located in the southern part of the Mae Hong Son Fault, was generally reported on tectonic geomorphology without dating information. Therefore, this study aims to investigate geomorphological features of the Mae Hong Son Fault using digital elevation model with high resolution, and to evaluate paleo-earthquake by excavating paleoseismic trench. From the figure 1, is it a enhanced SRTM DEM data show the lineament of the Mae Hong Son Fault segment, which oriented in north-south direction, cover Mae Hong Son province and northern part of Tak province. And this figure shows the location of the Metalut site, which is on the southern part of the Mae Hong Son area. And photograph of the location of the Metalut site show the north trending mountain range, show the triangular facet in the yellow line, and the red line show the Metalut Fault segment. And the photograph of the drone image processing show the location of the trench located in the Mae Hong Son Fault segment. We call the Metalut site or Metalut Fault segment. However, trench section and interpretation from 3D trench model was created using photogrammetry technique by Agisoft Metashape software. The trenching investigation of the Mae Hong Son Fault are conducted for revealing paleoseismic events. The 3D trench model shows the characteristic of the sediment layer on north wall of the Metalut site. It composed of the point count, dense count, model wireframe, and model texture. This model shows the Metalut site that excavated to help reveal structure of fault and soil sample that's related to the fault in the trench were collected for SL dating. When we got the model of the trench wall, then we interpreted the fault orientation and OSL edge of sediment layer on north wall of the Metalut site. As a result, the Metalut segment, with a surface rupture range of about 8.8 kilometers, can generate the maximum credible earthquake magnitude of 6.2. Based on stratigraphic modeling and statistical comparison of OSL dating that we collected from the trench wall, we can estimate the largest earthquake at the Metalut segment about 44,000 years, and the mean offset of the stream at the Metalut segment, which is about 4 meters, can give rise to an average slip rate of the Metalut site or Metalut Fault segment is about 0.09 millimeters per year. So all of these are our research in about for displacement, accommodation, and slip rate of the Mae Hong Son Fault, especially Metalut Fault segment. Thank you for your listening. It was a pleasure to be here today. Thank you, everyone. Thank you.
Hello everyone, my name is Kantarat Takulvirayut from Mahidol University, Thailand. Today I would like to present the poster entitled Stratigraphy and Paleontology of the area between the Ban Phuk Pru to Ban Khao Sam Chan, Sayok District, Kanchanaburi Province, Western Thailand. Let me introduce about Sayok area. Okay, I will show you the map. You can see in the map, Sayok is district on western side of Kanchanaburi province, the western part of Thailand. In the Sayok area, carbonate rock are exposed as karst topography and widely distributed. For a long time, this carbonate rock unit was assigned and mapped as the Permian Library Group. Within study area, you can see Ban Phuk Pru in southeastern part, and you can see the Khao Sam Chan, Ban Khao Sam Chan in northwestern part of our study area. Our study area is composed of the massive limestone and also dolomitic limestone, which assigned and mapped as the Permian Library Group 2. However, the much more precise stratigraphy has not been studied yet. Now, I would like to present currently result on stratigraphy and new paleontological data from Sayok area. Okay, we look at stratigraphic column. The carbonate substation in research area is approximately 1,300 meter thick, and it can divide into three members. First one, Phuk Pru member, the lower part of the substation. This member is characterized by thin to thick bedded limestone, and chert nodules are common in this member. Many foraminifera, especially fissurinid, were found in this member. The fissurinid in genera Eopoli, Fissurina, and Pseudofissurina from lower part are assigned to lower Permian in age. And also fissurinid in genera Eopolidiexodina that we found from the upper part is assigned to lowermost of Middle Permian. Okay, next to second member is Tham Seo Dao member. This member composed of bedded limestone with limited chert nodule. Some foraminifera were found, including Lectospicturina, Dagmarita, and probably Hemicodiagnosis, represent the uppermost of Middle Permian to lowermost of Upper Permian in age. Okay, next to the last one, Khao Sam Chan member. You can see I show in paper. The Khao Sam Chan member is characterized by medium to thin bedded dolomitic limestone. In this member, we found small foraminifera, in general Pyramina and Meadospira, which suggesting the lowermost of Middle Triassic in age. Okay, on our currently data, the Phuk Pru member and Tham Seo Dao member are conformable together, but the overlay Khao Sam Chan member is distinct unconformity that you can see in the map. The direction of rock are different. Unconformity between the upper part of Permian to lower Triassic, we suggest the substantial gap for approximately 15 to 20 million years. Okay. Finally, I would like to conclude this research. From our fieldwork observation on stratigraphy and fossil analysis, we confirm the age of this carbonate succession in Sayok area is widely ranged from lower Permian to Middle Triassic, and also probably to Jurassic in age in the northern side of research area. The unconformity and absence of the upper Permian to lower Triassic fossil represent the gap of the deposit for approximately 15 to 20 million years. Thank you for your attention.
Hello everyone, my name is Suvichai Chatuporn. I'm a master degree student in Geology of Chiang Mai University. Today, I would like to talk about the tectonic setting of the metatarth in the mapped Salient Union Unit, Kanchanaburi Province, Western Thailand. Let's start with the introduction. So the area is located in the Mueang District, Kanchanaburi Province, which belongs to the internal suture zone that represents the Paleolithic. This thesis was located between the Cebu Massif and Indochina terrain. However, the internal suture zone is not only Paleolithic remnant, but also includes the tasselite of the Cebu Massif basement. Moreover, these metatarths have been published the second age dating. They were emphasized in the Cambodian related to the subduction of Paleolithic. This figure is show geologic map of the study area that consists of Cambrian, Ordovician, Silurian, Devonian, Triassic, granite, and unconsolidated quaternary. This study focused on the Silurian Devonian unit represented by the brown area. The details of petrography and geochemistry of this rock are still unclear and insufficient. Therefore, we report the petrographic and geochemical data. Move to the petrography. The metatarths can be classified as the metaquartz, feldspar, pixel and metallithic tarth. They were made up mainly of verified to coarse-grained volcanic particles or pyroclasts, and perhaps mixed with non-volcanic particle or epiclast embedded in the highly altered liquidified fine ash matrix. Move to the geochemistry. Based on the immobile element classification process, the metatarth can be classified as trachyandesite, dacite, and levolite. And the condensed normalite layered element pattern display the lightly enrichment with nearly flat of heavily and show the negative European anomaly that is typical for the calc-alkali volcanic rock. This shows the primitive mantle normalized spider diagram. The metatarths show the negative niobium tantalum anomaly, which indicate the magmatic arc signature. Move to the tectonic setting. Most samples fall into the volcanic arc granite field in the granite discrimination diagram of PS 1984 using the rubidium, niobium, yttrium, tantalum, and ytterbium. And like with the discrimination diagram of Wood 1980, all samples fall into the calc-alkali basalt that also relate to the subduction. In the conclusion, the method have from the Kanchanaburi were emphasized in the late Cambrian to early Ordovician. They are Trachy and Dacitic, and Laolitic tuff, and belong to the Cal-alkali series. The tuff were formed in an island arc environment related to the Proto-Cretaceous ocean subduction. Thank you for your attention.
Hello, all folks. Thank you for your interest in this research. My name is Thematic graduate student from Department of Geological Science, Faculty of Science, Chiang Mai University. In this section, I am going to talk about characteristics of igneous rocks from the Sukhothai zone during the late Permian to early Jurassic, evident for changes in formation depth by trace element content. Formation and emplacement of magmatic rocks are well documented in the Sukhothai zone in Southeast Asia during Permo-Triassic to early Jurassic times, approximately 250 until 180 megaamna. The observed magmatism in Sukhothai zones point to long life subductions with synchronization and post-corrosion events. The geochemical data igneous rocks from southern China, northern Thailand, and northwestern Laos in order to document the changes with time at which crustal level partial meltings occurred. Strontiums, yttriums, lanthanum ytterbiums, and holmium ytterbium ratios in igneous rocks are sensitive to depth of melt formation due to the presence or absence of high-pressure minerals such as garnet, amphibole, or another. This ratio rise with depth formation, thus indicating increasing crustal thickness. Therefore, those ratios were used to reference change in crustal thickness and hence depth of magma formations. And I use the equation that calculates Mohorovich is 1.1 of strontium near ytterbium ratio plus 8.5 kilometers for calculate the depth in kilometers for the Mohorovich. The subduction phase started in the late Permian and went at Middle Triassic times. Geochemical data which indicates in high of those ratio allow documents of crustal thickenings formations of melt at high depth at around 250 until 240 megaamna. This event is also associated with the closing of non-Uttaradik backyard basin. The liolite sample from Chiang Khong area might be product of an arc to synchronization tectonic setting around 240 megaamna. This one. At approximately 240 to 220 megaamna. Lower of those elements ratio occur. It indicates shallower melting depth related to crustal thickenings and extensional in this time. However, igneous rocks will intrude around 220 until 215 display slightly evaluate ratio, indicating a deeper source of kinetic magnetisms if compared to 240 and 220 megaannum. The last one is extensional and thickenings of continental crust occurred during early Jurassic, confirmed by lower of those elements in this period. And while comparing with the relationship of compressional event and extensional events on the basin formation of and metamorphisms in northern Thailand, were found that extensional events approximately 240 until 220 megaannum was related to Lampang and Songkups in this area. The compressional events around 220 to 215 megaannum related with the high peak of metamorphism in northern Thailand. And the last one is the extensional of continental crust occurred during the early Jurassic, associated with the deposition of Mesozoic late bed in northern Thailand. The changes in depth of magma formation from the late Permian to early Jurassic in Sukhothai zone is consistent with the transition of volcanic arc into a post-corrosion extensional development, which is related to cross of the Paleotritic Ocean. Thank you for your attention. And if you have a question, please feel free to comment in this section. Thank you.
Good afternoon. Hello again, and welcome back to our session, our last session of the 2020 CCOP thematic session of this year. A special online international meeting conference. So our session will be on geodata and information, geoenvironment, climate change, hazard, urban geology. Continue from this morning. Now we changed the chairperson. I will be the chairperson, and with co-chairing with Professor Dr. Panya Charu Siri from Thailand also. Now I'd like to introduce myself and also Professor Panya. So I transformed from an MC to a chairperson, so it's probably nothing wrong to introduce myself as well. My name is Titik Tulayatik. I graduated from Chiang Mai University long time ago, lost my count, and master degree at Queen's University, Kingston, Ontario. During that time, I also have my senior, which is Professor Panya Charu Sri, who also share the same supervisors. So now we are sharing together like brothers. Okay, and I also got my PhD from the United Kingdom, from Leeds University. My specialty, I used to work a lot on the airborne geophysical survey, and there are a lot of things that I've been working. But anyway, now I'm working with the CCOP Technical Secretariat, and I'll be chairing the session. And for Professor Panya Charu Sri, he is also a Thai person. He representing the Geological Society of Thailand, and he got his PhD degrees from Queen's University, as I mentioned earlier. And his specialty is expertise is in field geology. That means a lot to geologists. And also he is expert on tectonic geology, especially for Thailand and regional tectonics and metallurgy, and mineral exploration, active tectonics in particular. And that's it. I think we can start our session. I'll be leading first, and then Professor Panya will be a couple more later. Yeah, and we have changed the program a little bit. The second presentation of this afternoon by Sen Wang will be cancelled because of the technical problem. And also we decided not to have the coffee break. So it's going to be a long session. We already have finished all the video clips for the poster presentations. And because we have only a few papers left if we have the coffee break, so we decided that we're not going to have a coffee break. You can bring your coffee, sitting in front of the computer and enjoy the talks and ask some questions. That'll be all right. Okay, our first presentation will be given by Susumu Nonogaki. His presentation will be on the 3D geological mapping of the central Tokyo. Dr. Susumu Nonogaki,
yes,
from Japan. He is a senior researcher. He has got all the bachelor, master, and the PhD from Osaka City University, Japan. And his expertise is on geological modeling, GIS, and analysis, web mapping, and geoinformation. Nonogaki-san?
yes.
Please go ahead. Thank you.
Thank you very much for your kind introduction, Chairman. I'm Susumu Nonogaki from Geological Survey of Japan. Today, I would like to talk about 3D geological mapping of central Tokyo. This is a work in cooperation with Tokyo Metropolitan Government. This is an outline of my presentation. First, I will introduce background of this work. Then I will talk about 3D mapping, focusing on methodology. And then I will show you provisional geological model. Okay, so let's move on to first topic, background. Recently in Japan, due to frequent disasters caused by large-scale earthquake, there is growing concern over geological risk in urban areas. For example, in 2011, artificial hills in reclaimed land caused liquefaction disaster like this. And in 2016, earthquake, thick volcaniclastic deposits caused suburb house damage like this. So to meet this demand, GSJ has published paper-based 2D geological maps so far like this. However, in 2D map, due to a space limitation, we cannot adequately describe subsurface geological condition, in particular beneath the urbanized coast plain, where geological layers tend to be horizontal. So to solve this problem, now we are carrying out 3D urban geological map project. In this project, we mainly do two works. One is a 3D modeling using borehole roads by GSJ and local governments. And other one is a development of web system for sharing 3D geo information. To date, we have finished northern Chiba area, eastern parts of Tokyo metropolitan area, and released the result on Urban Geological Map website here. On this website, the user can see 2D and 3D geological map, borehole roads used for mapping, and can create geological cross-section along arbitrary line like this. So now, for seamless 3D mapping of Tokyo metropolitan area, we are working on central Tokyo area, cooperating with Tokyo metropolitan government. So, okay, from next slide, I would like to talk about current progress of this study, focusing on the 3D mapping methodology. First, study area. Study area is the special words of Tokyo, Japan, outlined by this red line. This area comprises three parts geologically, that is, upland with Pleistocene deposit, lowland with Holocene deposit, and reclaimed land along coastal parts. This slide shows borehole roads in study area. As shown in left figure, there are more than 60,000 borehole roads in this area. Most of them were created for public construction work. And almost cases, and these are accumulated by Tokyo metropolitan government. And almost cases, borehole road has resources descriptions and standard penetration test result called SPTN values. And they are provided by XML format. In our project, we utilize these dense borehole roads to figure out distribution pattern of subsurface geology. This is a mapping flow. First, we carry out drawing survey and laboratory works and establish standard stratigraphic framework in study area. Next, based on this framework, we carry out strata correlation using borehole roads for public construction work. And thirdly, using correlation result, we generate digital elevation models of geological boundaries and construct 3D model. And finally, release the result on the internet. In this workflow, here, strata correlation is one of the most important and time-consuming process. This is a capture image of strata correlation process. This is borehole roads by GSJ, and others are the ones by local government, Tokyo metropolitan governments. In correlation process, based on GSJ roads, we specify depths of geological boundaries at each borehole location using geotechnical properties such as resources and SPTN values. However, when borehole roads are far apart, it's often difficult to specify the depths and cannot connect like this. So to assist the correlation process, here we construct voxel model of geotechnical properties from local government borehole roads. This is voxel modeling flow. In the voxel modeling of geotechnical properties, first, we regularize geotechnical properties stored in borehole roads and get 1D regular grids. like this. And at the same time, we perform Voronoi tessellation using borehole locations and get Voronoi diagram, 2D Voronoi diagram. And next, we carry out 2D interpolation of geotechnical properties at each elevation and get horizontal 2D grid like this. And finally, by stacking a series of horizontal 2D grids at regular elevation intervals like this, we get a voxel model. This is an example of strata correlation using voxel model. As shown in a broken red line frame, geotechnical properties derived from voxel model are displayed between borehole rows, and it assists the correlation process. Like this, we use voxel model of geotechnical property in strata correlation. These voxel models are useful also for overviewing a subsurface condition. These are slice images of voxel model in central Tokyo. Left one is risk fascists, and right one is SPTN values. In SPTN values, white means a soft sediment, red means a hard sediment. We can see thick, very soft sediment beneath lowland. These sediments, in particular, these yellow, soft, sandy sediments, have the risk of liquefaction. This is an example in upland. In this case, we can see soft muddy sediments and a hard gravel bed. Here, this one is hard gravel bed and this one is soft muddy sediment. These sediments have the risk of amplifying earthquake ground motion. Like this, voxel model is used for overviewing a subsurface condition, as well as for assisting stratal correlation process. Now, stratal correlation and 3D geological modeling process are in final stage. This is a provisional 3D geological model in central Tokyo. In provisional model, we can confirm detailed distribution pattern of some soft geological layers like this. Here is Holocene layer and here is Pleistocene layers. We expect these results to contribute to increasing the accuracy of the geological risk evaluation. 3D geological map of central Tokyo will be released in next year. After that, we plan to move on to surrounding areas. That's all, and thank you for your attention.
Thank you very much. Are there any questions from the floor? Yes, please. Dr.
Okay.
Pena.
Thank you very much for a very nice talk and very informative. You drill over 6,000 boreholes.
Yes.
The depth, the maximum depth of those holes?
Okay. Maximum depth is maybe I don't remember actual value, but about 100 meters and averagely 30 meters.
30 meters, 200
yeah.
meters.
Yes. Maximum is 100.
400.
Yes.
And you mentioned about Pleistocene valley filling soft muddy sediment.
Sorry?
You mentioned about the Pleistocene.
Yes.
And the Holocene.
In upland area, Pleistocene, and the lowland area, Holocene.
The lower area mainly Holocene.
Yes, mainly Holocene.
And how thick those sequences?
It depends on the area. So how I can say, deepest. I'm not sure the but maybe maximum depth is 60 meter.
The Holocene.
Around 60 or 70 meter.
Okay, thank you. 30 to 60 meters. Thank you.
Thank you very much for the question.
Okay, thank you very much for very nice and interesting topics and interesting result coming. So what my question is it very good for actually some applying for the urban geology issues?
Yes.
This is quite critical issues all over the world and especially in Southeast Asian area. So my question is that what is the resolution of your 3D geological map?
Okay. Horizontal resolution is now we use 5 meter DM, so that has 5 meter. But it's a resolution of the model. Sorry, grid interval of the model, not actual resolution. And vertical resolution depends on the depends on the area. So if we have relatively many borehole data, the resolution becomes high. So some area has a very high resolution, and some area has relatively low resolution. But now we create with 5 meter resolution horizontally. It's okay?
Thank you. Okay, thank you very much. We need to move on then. Thank you very much.
Thank you very much.
Yeah, Dr. Nonokakis. Our next speaker would be Youngjun Kim from the Republic of Korea. His title of his talk would be Multi-Scaled High-Resolution Seismic Approaches to Identifying the Geohazard in the Coastal Area. Dr. Youngjun Kim, he is now a senior researcher. He's got his bachelor, master, and PhD degrees from Korea Maritime and Ocean University, Republic of Korea. His expertise will be on the marine geophysics and high-resolution seismic. Dr. Youngjun Kim, please.
Good afternoon, ladies and gentlemen. I'm Youngjun Kim in Kigam. I'm pleased to be able to make a presentation for you. Today, I present for multi-scale high-resolution seismic approaches to identify the geohazard in the coastal area. My key point is the detection and investigation of geohazard factors using the high-resolution seismic survey. The contents of the presentation are as follows: introduction, and I'm introducing the difference between conventional seismic survey and high-resolution survey, and then mention about recent two-case surveys conducted in Kigam. The roles of coastal area are evolving gradually, living space, fishery resources, port, logistics field, maritime industrial base, and space for leisure and travel. Large-scale civil engineering construction, such as huge bridges, submarine tunnels, wind farms, and offshore cities, is continuously carried out and planned. Geohazard disaster induced by natural process or human activity, marine geological disaster cause loss of life and property. Earthquake, volcanoes, seafloor event, and related tsunami have tremendous destructive power. Other generally do not cause direct damage to societies but can affect engineered structure. These include pongmark, mud volcanoes, and mobile bed foam. In addition, due to global climate changes, we don't know exactly how it can change it to trigger or not to geohazard impact. As a geophysicist, we have to precisely identify potential risk impact of geohazard. So I would like to introduce the difference between conventional seismic exploration for resource purpose and high-resolution seismic exploration. The conventional seismic survey uses an airgun array consisting of a single array of airguns of various capacities. The streamer as the seismic receiver employed a length of several kilometers. The target depths can reach several kilometers. On the other hand, the target depths of high-resolution survey ranges from seafloor to within 200 meters. The kinds of seismic source are mini-giant sparkle boomer chop system. The receiver is used a single channel or a short multi-channel streamer. In other words, the frequency of hydrocarbon exploration range is less than 100 Hz. The frequency of high-resolution seismic survey ranges from 100 Hz to 3 kHz. This figure is seismic sources that are widely used high-resolution seismic survey. In this slide, the seismic section compared according to seismic source. These data sets were acquired in gas hydrate project at Ulung Basin, East Sea. We could not confirm that the fault extended the seafloor on the seismic section was because the wavelength 20 milliseconds. However, we can observe that seafloor, the sea bottom was deformed by fault. The deeper sediment mantle layer is from sea bottom, the more apparent the fault offset becomes increasing gradually. The spark section shows teeny offset changes on the sea bottom. This slide shows that the seismic section acquired by Sparker and Boomer are compared. Both seismic sources are used in the representative high-resolution seismic survey because of cost effectiveness and easy operation. The dominant frequency Sparker range is 200 Hz. The Boomer dominant frequency range is 200 to 500 Hz. The penetration of spark section is deeper than Boomer. This section shows clearly the spark picture is seafloor expressed by two lines because of the second bubble effect. Now I show two case studies performed by KIGAM. First case study is about the detection of fault. 2016, 2017, 5.8, 5.4 magnitude earthquake occurred in Gyeongju and Pohang. Following this seismic event, a new project was started in 2018 to identify and map active faults that could potentially cause earthquake. We can observe that small offset on the sea floor. So to investigate a fault, we conducted the various seismic survey. Also, we carry out high resolution 3D seismic survey. This line is overlapped about 4 kilometers. All data was acquired by KIGAM's research vessel TAMET-2 for the wide area. The 2D high resolution seismic survey is acquired by Sparkle and 16 channel streamer. At the in the 3D high resolution seismic survey on mini GI gun and the 2 8-channel streamer. At the same time, we obtain the CHOP data and multi-beam echo sound data. This slide compares the survey result along the red line in the track chart. This figure shows bathymetric map. The water depth was from 110 meter to 250 meter, and the depth increased rapidly toward the west. A change in the seafloor topography was observed. The offset is approximately 7 meters. The change was oriented northwest by southeast. On the top section, the change in the seafloor topography was confirmed. This interval, the penetration depth of the CHOP depends on the type of sediment, because the CHOP could not penetrate sea bottom. It could not be determined whether the sub-bottom and underlying sedimentary layers had the same change. The CHOP section showed the seafloor erosion at the slope. This text section This text section was obtained by the Spark source, but reflected event for lower sedimentary layer, but it is difficult to identify events. Thus, there is no evidence of a change in seafloor topography. Entire section contains low frequency noise. Final section, mini GI gun text section. The wavelet signature of the seafloor is sharper than Spark section. The penetration depth is also deeper, which allows confirmation of event in lower layer appearing at 700 milliseconds, 2-way travel time. Reflection from the lower layers on the seafloor are observed in seafloor topography change zone. The continuity of the reflected event is interrupted based on this zone. Second case study is about the shallow gas. In the southeastern continental shelf of Korea, gas charged sediment have been reported.
You have 3 more minutes left.
Okay, been reported in Korea straight shelf mud deposit. These gas charges sediment are characterized by velocity pull down near the top of the acoustic blanking zone. These are characterized by very thick, organic, rich, muddy sediments and underlying descending sediments. They cover an area about 900 square kilometer with good lateral continuity over a distance of about 9 kilometers along the coast from Busan to Pohang. We performed in October in this year. The survey area was located Ulsan Port. So survey vessel is small vessel. We used in 1,000 kilometer sparkle and single channel streamer and two frequency band chop system. This slide shows the screen capture of chop data acquisition software. This system obtains both low frequency and high frequency data. In this survey, we set up like that. In the section of low frequency, we can observe the acoustic blanking. On the other hand, the high frequency section until top of acoustic blanking zone. The boundary of the shallow strata is better seen. By comparing the two sections, the gas chimney can also be detected. I show you the spark section and low frequency chop section. This section has frequency band of from 200 Hz to 1,200 Hz. The acoustic basement has appeared on the acoustic blanking.
I'm afraid you have to wrap up your talk now.
Okay, we can confirm the relation between the distribution pattern, shallow gas, acoustic basement. Yeah. I show the result of the high resolution seismic survey conducted at the site of the fault and shallow gas in Korea. To confirm the fault offset, we conducted a high resolution survey using mini GI-gun and 8-channel streamer and chop. Also, to detect the fault orientation, we obtained the multi-beam echo sound. To identify and detect more detail, the indirect evidence of geohazard, we need to combine the result produced by data acquisition system operating in different frequency ranges. Thank you.
Thank you very much, Dr. Yong Jun Kim. Are there any questions from the floor?
Just very quick questions. Only fault that you mentioned for your geohazard, is there anything else that's like landslide or some other thing, just like big hole beneath the seismic line survey or something like that? Only one case?
I'm sorry, I don't understand your question.
So what I mean is, you mentioned only fault, which
Yes.
Represent the based on your seismic interpretation. Are there any kinds of geohazard which may have used by using your seismic data? For instance, something like a submarine landslide or something like subsidence, land surface subsidence, based on your experience on the seismic survey.
Yeah. This year we surveyed for submarine landslide using the high resolution seismic system, acquisition system, and multi-beam echo sound. So yeah, now we we process the data, seismic data, and then yeah.
Yes.
Thank you. I just very short question. When you mentioned about the shallow gas,
Yes.
How shallow? How many meters?
Yeah, this shallow gas is sub-bottom, so about 20 meters from the sea floor to connected to 20 meters.
Okay. Well, I think there are a number of questions for you in your chat. So in order to save our time, can you answer your question according to the chat? And yes, for now, well, thank you very much. And please give Dr. Yong Jun Kim a big hand for his excellent presentation. We continue with the next talk, which will be given by Dr. Ho Rim Kim. Dr. Ho Rim Kim from the Republic of Korea. He is now a senior researcher at KIGAM, and he has got a bachelor degree, master degree, and PhD from Korea University, Republic of Korea. His experience is on programming and geochemistry. So Dr. Ho Rim Kim, the floor is yours now.
Thank you for giving chance for presentation. My name is Horin Kim in KIGAM. Before I begin, I just really wanted to make a point of acknowledging all of our collaborating authors whose work has really expanded my ideas. We'll take it from here to talk about the machine learning method for spatial assessment of geoscience data set using real soil contamination site. Assessing the spatial distribution of soil contaminant is an important step for the management and remediation of contaminated site. As shown in the left figure, the smaller the difference between the real population and the estimation, the lower the cost of soil remediation. It's an ideal situation for the soil remediation. But in most of the real world, the larger difference between the estimation, the population often occur like figure, the cleanup area are under or overestimated. And this erroneous evaluation may lead to both environmental and financial risk. However, the assessment of contaminated areas is often deteriorate because of limited sample size on the budget and time constraints. Therefore, we often have contradictory objectives in that minimizing the sampling density and maximizing the estimation accuracy. Meanwhile, geoscience datasets are commonly contain quantitative, complex, and multivariate properties, just about all complex datasets from the real world. Therefore, the multi-resolution integration approaches are needed for many geoscience application fields to take into account the spatial structures and multivariate complexity. In many geoscience applications, high-dimensional data have become standard with the increasing availability of multiple measurements, such as the development of ICT technologies. So today, we propose multi-resolution geoscience data integration approach using the Gaussian mixture model, here up to GMM. To prove the usefulness of GMM, we compare the performance of and accuracy of GMM conventional approaches, including the ordinary kriging and co-kriging, hereafter OK and OCK at different sampling densities. Next, let me explain the method and statistical approaches. The soil contamination site near the former Chang'an smelter was used as a detailed investigations. The Korea Ministry of Environmental MOE documented that the arsenic and lead in soil exceeded the Korean regulatory limits. The study areas represent a 3,000 meter scale area, so 6 soil samples are enough according to Soil Act of Korea. However, we collected 153 samples to better evaluate the spatial extent of soil contamination. The samples were analyzed using ICP collected at depths of 0 to 20 centimeters. For laboratory analysis, the pre-treatment method of ISO was used. In addition, at the same sampling locations, arsenic and heavy metals, including the lead, copper, nickel, zinc, were scanned in the field using the portable XRF spectroscopy. In situ, PXRF field analysis was applied based on the non-destructive analysis method of US EPA, and soil sampling and chemical analysis were performed by NICEM. Comparison of soil contamination by portable XRF and the ICP. The conventional method, such as the ICP, have many advantages, such as a highly accurate, but it requires the collection of extensive soil samples and laboratory preparation. So this is severely limited by both the high cost and the time consuming used in pre-processing. On the other hand, the PXRF spectroscopy is a low-cost, rapid, and easy method to obtain auxiliary variables. It does not require sample preparation, including air drying, crushing, sieving, and acid digestion. So we take gross analytical method for construct multi-resolution dataset, and a total of 10 soil samples were obtained. We apply 3 spatial estimation. First, the univariate OK, the bivariate OCK, and finally, we use the multi-resolution techniques using the GMM. A step-by-step description of the detailed procedure uses as presented in this figure. First step, to identify the important variables. Firstly, we explore the data correlation, and secondly, implement a feature selection algorithm using random forest. Next step, split up dataset into training and test. And the 7 training datasets were randomly selected from the training to compare the performance of sampling density. Step 2, the before conducting geostatistics, spatial dependency, so auto variography and cross variography were determined for each training dataset. Next to for GMM, EM algorithms were applied to estimate multiple probability distribution. Finally, for each training data set, we compare the performance of OK and OCK and GMM. Now let's move on to result and discussion parts. Firstly, I like to check for reliability of PXRF data. PXRF tend to underestimate the real heavy metal concentration. However, these two data sets show a highly positive correlation, indicating that the PXRF are enough to be effectively used as an auxiliary variables. This figure shows the correlation matrix. The top of the diagonal lines show the correlation by a variable, and the left star means the confidence level. Significant reliability and high correlation in arsenic and lead, arsenic and copper, and lead and copper. It suggests that the copper may also be considered a product of the smelting process, although it did not exceed the laboratory limits. Meanwhile, the PXRF nickel and zinc have low correlation with other variables. This figure shows that the future selection result for arsenic and lead. The green means the important variable, yellow and tentative, red means rejected and unimportant variable. These results indicate that the potable XRF nickel and zinc were rejected using future selection, which is constant with the result of linear correlation. We estimated multiple probability distribution of latent variable using the EM algorithm. The best GMM can be selected based on the highest BIC, and the bimodal distribution is an appropriated probability distribution in this series. In other words, this bimodal pattern is caused by the complexity and nonlinear nature of heterogeneous system. So we apply three methods. Figure A, that means the univariate, the bivariate OCK, and multivariate GMM using about 30% in the total training data set. The figure D means the OK result using the total training data set, which were assumed to ground the truth. On method effectively estimating the contaminated areas in the West. However, the OK for arsenic failed to detect the low concentration spot in the center of the areas. In contrast, the OCK and GMM using 45 training data set and the spatial distribution of arsenic concentration similar to entire data set. This confirms that the multi-resolution data set provide important information such as the heterogeneous arsenic patterns that were missing in the 49 training data set. The accuracy of three methods in terms of root-mean square error and Pierce correlation coefficient were assessed using the test data set at different sampling density. As the sample size increased, RMS3 decreased, and the coefficient increased in all methods. And the GMM in the lowest RMSE and higher coefficient than OK and OCK at each sampling density, which indicate that the GMM has the better performance. So this
2 minutes left. Sorry.
Okay. This result confirms the effectiveness of the multi-resolution integration approaches To sum up then, the results from GMM generally provide the lower RMSE and the higher coefficient indicate the usefulness of multi-resolution information in delineating soil contaminants distribution. The use of GMM could improve the performance of the interpretation of spatial distribution in soil contamination and other application fields. Finally, this study demonstrates that the multi-resolution integrated approaches can be effectively applied to understand complex and heterogeneous geological and geochemical features. Thank you for your attention.
Thank you very much. Are there any questions from the floor? I really have a quick question for you. How many data sets have you been experiencing? Are you going to come up with a similar result that you summarized?
I'm afraid I don't. I could not catch your question, please.
Oh, okay. I'm asking how many sets of data that you tried with this in order to make sure that your summary is okay.
In my case, we just use the 30%. In the case of 49 training data set is fully estimate the total, the grounded truth. But it's a case by case.
Okay, if there's no other question, then thank you very much.
Thank you.
Dr. Ho-Rin Kim, for your excellent presentation. So we continue with the next presentation, which will be given by Dr. Firdaus bin Ahmad from Malaysia. His presentation will be on the slope hazard and risk mapping project, an overview of disaster risk reduction initiative. Dr. Ahmed has got his bachelor degree from University of Malaya and has got his MSc and PhD from University of Leeds. So you went to the School of Engineering in University of Leeds. Well, that's my alumni. So I went to Leeds also. And also the Dr. Samai, I think he also went to the same school as you. Yeah, so Dr. Ahmed experienced in subsurface geological mapping, and he has been working on dam, tunnel and safety inspection, that sort of thing, and geological hazard mapping. So welcome, Dr. Ahmed. The floor is yours.
Sorry, just for a while.
Yes, okay, go ahead, yes.
Yep. Can you hear my voice?
Yes, yes, very clear.
Okay, thank you very much. Good afternoon, everyone. Thank you very much to Mr. Chairperson for a kind introduction. So I'm Firdaus bin Ahmad from Department of Mineral and Geoscience, Malaysia. The title of my talk that I'm going to share today is Slope Hazard and Risk Mapping Project, or also known as TBRC, an overview of disaster risk reduction initiative. As we know that for introduction, extreme climate, rapid urbanization and environmental degradation substantially increase exposure and vulnerability to natural hazards, especially for landslides and disaster risk in developing tropical country like Malaysia. So therefore, it's very important to address the issues and possible solutions related to the natural hazards in an objective and quantitative manner. So Malaysia plays a role towards the success of the initiative listed in the Sendai Framework for Disaster Risk Reduction 2015-2030, which is a successor instrument to the Hyogo Framework for Action 2005-2015. As you can see from my slides, there are a few examples of landslides, especially in Cameron Highlands, which is high elevation tourist area. You can see from the side, the toe of the landslide is buildings and roads, and not only that, on top of the landslide as well, there are a few buildings and hotels which pose risk. Therefore, Malaysia government thinks that it's very important to come up with a certain project to overcome this problem. So the Project Penghasilan Peta Bahaya and Risiko Cerun, or PBRC, or the Slope Hazard and Risk Mapping Project. It is the first national project that tackles the issues of area-based landslide hazard and risk. It uses multi-sensory light detection and ranging, or so-called LiDAR technology, which is supported by many expertise and disciplinary partners, such as engineering geology, the technical engineering, land survey, remote sensing, as well as GIS. As in this slide, you can see that there are a few erosions and landslides with different size. This is due to agriculture, and we add certain areas in uncontrolled agriculture and cultivation activities. So we have to tackle all these things. So at the moment, the Slope Hazard and Risk Mapping projects under Ministry of Energy and Natural Resources of Malaysia, where from this project, we acquired the orthophoto and point clouds. That from that, we come up with a digital terrain model, digital surface model, contour, as well as drainage pattern. PBRC. In Malaysia, we have a National Slope Master Plan, NSMP, starts 2009, and then we end on 2023. So PBRC is one of the action plans formulated under this National Slope Master Plan. So it has been formulated to effectively build resilience of nations and communities towards disaster. You can see in the slide, due to a landslide, which is nearly 500 meters in length, and a few couple of meters in width of landslide, damaged the road, and then a few houses on top of the landslide. This landslide occurred in Sabah, which is in East Malaysia. Well, ladies and gentlemen, the PBRC, we have 4 main objectives. The first one is to produce slope hazard and risk information, which is in thematic maps in the selected areas for the local authorities in Malaysia for better slope management, and also to have a conceptual proposal and cost estimation for mitigating and strengthening high-risk slope. Another objective is to assist government agencies and local authorities in land use planning towards sustainable land management. Last but not least, to develop geospatial infrastructure for national geological terrain and soil information. It's more on database of a landslide in Malaysia. As I mentioned earlier that we have a National Slope Master Plan 2009-2020, and this National Slope Master Plan has identified 22 landslide-prone areas. 5 of these landslide-prone areas has been carried out for PBRC project. PBRC project has been carried out in 2 phases. Phase 1 carried out in 2014 to 2016, which covered 1,350 square kilometers. And then for phase 2, 2017 to 2021, covers 500 square kilometers. And all the total area of this from 2014 to 2021, same years, covers 1,850 square kilometers. You can see that very clearly from this figure. The phase 1 consists of Ipoh, 200 square kilometers. Lembah Kelang, where Kuala Lumpur is located, 650 square kilometers. And Cameron Highlands is a tourism area, and Kota Kinabalu. as well as Kundasang, 70 square kilometers. The interesting part of this project is we cover not only for urban area, but for 5 different geo-environment, which is urbanized area, and then mountainous region, geoheritage site, urban and suburban or rapid urbanization, and also in tectonically active region, which we have a very high number of earthquake, that's in Sabah. For methodology, implementation of framework for slope hazard and risk mapping consists of nearly about 10 steps, yeah. And then from data acquisition, then the processing of the LiDAR data of point clouds, and then derivatives of parameterization, and then landslide inventory mapping based on LiDAR data and fieldwork, as well as analysis for susceptibility, hazard and risk assessment. Last but not least, for geotechnical risk assessment. In details, the workflow, the phase 1, we can put it in phase 1, that is field data collection. This phase dealt with multi-sensor active remote sensing data collection and pre-post processing coupling with reconstruction of historical data and associated events, compilation of archive data. All this we also combine, we employ airborne laser scanning using either fixed wing or rotary wing, depends on the geomorphology of the area, and also terrestrial laser scanning. For phase 2, we proceed to landslide inventory mapping and LiDAR parameterization, especially from the LiDAR data. It's a very critical stage for hazard and risk assessment. A series of causal factor maps is developed by advanced LiDAR data analysis, like hydrotopographical causal factors, anthropogenic, geological causal factors. And also we'll consider about geomorphical factor maps. Yeah? Combine the LiDAR data with expert judgment and local knowledge supported by intensive field verification and validation. For your information, this project, the approach of this project is semi-quantitative, means that the combination of statistical method and heuristic method, which we combine with expert judgment. For landslide susceptibility assessment, yeah, sample of causal factors consists of lithology, distance of lineament to lineament, land use, and for geological factors, geomorphological factors as well, we consider about the slope map, curvature map, aspect map, as well as hydrotopographical factors like watershed, channel, stream network, and also among the important factors is anthropogenic. Sometimes in Malaysia, that's why you cover a certain area where we have a cultivation agriculture area. So it is very clear that anthropogenic factors is one of the major factors that can cause a landslide. So for analysis, we use a bivariate statistical analysis for the assessment. For phase 3, a landslide hazard and risk assessment. It involves components ranging from susceptibility, hazard, element at risk, vulnerability and risk analysis depending on many scenarios, as I mentioned, and then modeling schemes, parameterization subjected to site conditions and environment. The triggering factors that we consider in our study is only rainfall and earthquakes. And also, for element at risk and the vulnerability of individual structures, we consider buildings, pylons, roofs, and utilities. For cost information of individual structures, we obtain from various stakeholders. And the last and important output of this project is on the phase 4 geotechnical risk assessment, which it consists of geotechnical analysis on landslide. And then from there, we go to mitigation measures proposal and spatial planning for certain area. Assessment of critical slope, especially man-made slope, by utilizing existing slope hazard risk ranking system, and subsequently propose mitigation measures and estimate cost of the construction of the mitigation measures. For output and applications, this project have at least 5 main maps, that is landslide inventory map, susceptibility map, hazard map, vulnerability map, and risk map.
Sir, you have 3 minutes.
Thank you very much. And also, all these map, we have information gained from that, and a relative importance to risk management, such as landslide mitigation option, and the areas susceptible to landslide, and also for which area is suitable for development. We also come up with certain technical reports. So in details, for example, I would like to show you that there's one of a PBRC area in Kota Kinabalu, Sabah. That's in Malaysia here. It's Indonesia and Thailand here. It covers 155 square kilometers, where this area is undergone urbanization in Malaysia, very rapid, experience a various scales of landslide due to demand of physical development, human activities, the geology, sedimentary rocks, sandstone and shale, and alluvial deposits. Yeah, and then we use airborne LiDAR survey to carry out this using rotary wing helicopter and the detailed model. We obtain it to facilitate field mapping, execute slope hazard and risk mapping. So the results of this PBRC in Kota Kinabalu, Sabah, we obtained 1,126 inventories that have been made, where 868 slopes with sign of distress, plantation to fill. And we also identified 258 landslides. From the inventorized data, I employed for susceptibility, hazard risk, technical and critical slope assessment. So this is the example of the maps that we produce for PBRC in Kota Kinabalu, susceptibility map, hazard map, vulnerability map, and risk map. For the hazard rating, we found that there are about 6.6% in Kota Kinabalu has a very high hazard. It's categorized as a very high hazard, and then come to the very low hazard, about 16.3%. And then for the risk rating, about 0.2% of the whole 155 square kilometers is categorized as very high, and then very low risk, about 60 something. So by incorporating hazard and risk analysis and expert judgment, 35 slopes identified as critical slope. This is more important things that we convey all this message to local authorities and stakeholders. So all the critical slope we put into 3 categories, where different categories have a different action to be taken. The category 1 require immediate strengthening works. Category 2 just needs not immediate, the strengthening works. For category 3 require monitoring. So number of slopes is as mentioned in this slide. So other than this, another part of the important things about this PBRC is the National Geospatial Terrain and Slope Information System, so-called NATSIS. This is a kind of database where acts as a geospatial data bank, which can be shared among respective government agencies for special information on landslides, terrain, and slopes. But one who have all the data, we have to share to other people. In this case, we also share all this information to community and hazard zonation. At the local community level, the hazard and risk map are shared to provide clear information, and then distributing information to range on the range of possible damage, and also educating people and local community, and also planning and guiding a more appropriate training module on disaster prevention to community. And also we establish a community-based early warning system, and also for evacuation system. For conclusions, so from this project, we provide an efficient, effective slope management system, and also expedite delivery of advisory service based on our database NATSIS, and also alleviates awareness and preparedness among community stakeholders and other people. And also from the from NATSIS or database, we promote a data sharing amongst agencies. Summary, nevertheless, but there is still much left to be done. So the PBRC we consider as a great example of producing hazard and risk map that follow international standards and meet the need of multi-sector agencies. And also it can be used to assess tropical landslide geomorphology in an objective manner. Last but not least, for acknowledgement, we would like to thank due to Government of Malaysia. Yeah, as this project could not have been attempted without financial support provided by them, and also grateful to Department of Mineral and Geoscience of Malaysia for the support and assistance provided by the staff Finally, thanks are also due to PBRC team members for their technical assistance and guidance throughout the course of this project. Thank you very much, Mr. Chairman and others.
Thank you very much, Dr. Firdaus Ahmad. Are there
Yeah,
any,
you're welcome.
Yeah, are there any questions from the floor? It's okay. I mean, we can continue with the program. Yeah. Okay. Yeah.
Yeah.
One question from the Prinya.
Yes.
Yes, please.
Very interesting talk. I'd like to ask, what is the time frame of your PBRC project? How many years you're going to carry out?
Right. As I mentioned before, so at the moment, from 2014 to 2021, we covered 1,850 square kilometers. And we also have National Slope Master Plan where they identified 22 landslide prone areas. We only done 5. So we have done 5. So I think for the beneficiaries of this country, I think the time frame, we need at least another 10 years to complete all these landslide prone areas were identified by National Slope Master Plan. So it means that I would say if time permits, and then with a good things, so at least 10 years we have to come up. We can cover all this 22 landslide prone areas identified by National Slope Master Plan.
Yes. One more question?
Yes, please.
The PBRC project is only for slope and hazard?
Yes.
Slope and landslide?
Yes, it is.
Only for slope and landslide, right?
Yes, it is.
Yes, okay. Well, thank you very much, Dr. Firdaus Ahmed.
You're welcome, Mr. Chairman.
Yes, okay. We go on with the next presentation. Will be given by Dato Zakaria Muhammad from Malaysia. Dato used to work at the Department of Mineral and Geoscience, Malaysia. He's got the bachelor degree in geology honors from National University of Malaysia. And he also got the master degree in applying quaternary geology, Rigi University, Brussels, Belgium. He is now a chairman board of the Geologists Malaysia. And Dato Zakaria Muhammad, the floor is yours.
Thank you very much, Mr. Chairman. My name is Zakaria. I will present my paper entitled Landslide Vulnerability and Risk Assessment Guideline for Critical Infrastructure, Lesson Learned from Malaysia Experience. This paper actually involved many people. It's a group of consortium from private sectors, universities, and as well government sectors. Table of content of my presentation, the problem statement. I will touch a little bit about landslide vulnerability assessment methodology, objectives, suggested landslide vulnerability assessment method, focus group discussion, and of course result and the discussion. So for introduction, the Construction Industry Development Board has engaged consultant and focusing on the effort to support specific agenda related to SDG 11, Sustainable City and Communities, and SDG 13, Climate Action, by producing many guidelines related to construction industries. The guideline recommended an appropriate method for landslide vulnerability assessment and the subsequent risk analysis of any development with critical infrastructure in highland area. The guideline is intended to be used by local authority, institutional agency, and decision makers as a supporting tool for land use planning and prioritizing of landslide risk mitigation plan and risk management for sustainable development cities. So this document is been completed. So disaster risk is a function of hazard, exposure, and vulnerability. In Malaysia, development of vulnerability assessment was mainly focusing on flood hazard and very limited on the landslide hazards. So far, there's no guideline on standard method that can be utilized to assess landslide vulnerability and risk, especially for critical infrastructure in Malaysia. So landslide vulnerability of CI can be expressed based on qualitative and semi-quantitative and post-quantitative method. Due to the scenario in Malaysia, in this case, is the insufficient landslide damage record in Malaysia. So the consortium suggests landslide vulnerability method was developed based on qualitative indicator approach as an initial stage. So this is a basic concept. I will touch about the hazard. We use GMG methodology, already well established in Malaysia. For vulnerability, there is a guideline going to be used in Malaysia in order to come out with the risk for critical infrastructures. So basically, we have a qualitative and quantitative. For qualitative, the value were assigned by the expert based on experience and historical record of damage based on specific landslide type. Because each landslide is not like flood, landslide type, different type of landslide, for instance, rockfall and debris flow and others type of landslide, the impact is different. That's why it's quite difficult for the landslide. Qualitative risk analysis refer to analysis that use work form, basically, with numerical scale to describe the magnitude of the potential consequences and the likelihood that the consequences will occur. Whereas quantitative risk analysis are based on numerical values, but normally it requires a lot of detailed information. A suitable approach for landslide risk analysis should be determined based on the requirement by the authority. For example, scale of the mapping, and of course, essential information required for the producing this vulnerability index and risk. If you look at the landslide vulnerability assessments, there's a physical vulnerability assessment, vulnerability assessment, and also looking at socioeconomic. This paper focus on physical vulnerability assessment. I mean, looking at the damage to the infrastructures and of course the people affected by that. So basically, there's three tools being used for the landslide vulnerability assessment: vulnerability metric and vulnerability curve. In this case, we propose to use indicator-based vulnerability assessment because level of information and also level of knowledge, people at the local authority is a different level at all. So that can be defined as variables which are operational representative of characteristic or quality of the system. They are able to provide information regarding the susceptibility, coping capacity, and resilience of the system. So basically, vulnerability indicator for landslide hazard include the selection of relevant indicators, the identification of variables, their weightage, and finally their aggregate vulnerability index. That is what's been done for this in order to produce this guideline. So there is a limitation for IBM methods. Of course, advantage, the method can be implemented in absence of detailed information and popular for decision makers, especially if the resources are limited. Characteristic element risks are taken into consideration. But the drawback is the uncertainty in terms of selection of parameters, standardization, weightage, and aggregation, as well as availability of required data. So that's why we focus on the method, how to come out, select the parameters, and also standardize and how to cover the weightage and aggregation for index calculations. So the objective of the project to identify issues related to vulnerability assessment risk index of critical infrastructure and to review a best practice vulnerability assessment for benchmarking and to assess and develop the parameter, indicators, or landslide vulnerability assessment and risk index of critical infrastructure assignment level for each parameter. So this paper, I'll start on item number 3 only. So these are methodologies. We begin with the literature review, field data aggregation, and pre-processing geodata, and development of vulnerability and risk assessment method based on literature review, and series of focus group discussion with the expert of various critical infrastructure components, and implementation of landslide vulnerability and risk assessment using geospatial approach, because this is area-based, and validation of proposed method. That is on the left side. We begin with the initial risk assessment, and we identify indicator and sub-indicator and weight value from the literature reviews. Then after that, we have a series of FGDs with the stakeholder to determine cluster or indicator and sub-indicator. And after that, look at the consistency or tendency of the input from the participant. Then only we have internal experts, those are familiar with the landslide hazard and also damage of the landslide, especially those working on maintenance. Then furthermore, of course, at the end we come up with the special approach for that. So this is FGD for different groups, for dams, for roads, for buildings, and also for electricity pool. So these are parameters being identified for vulnerability index. First is critical susceptibility of critical infrastructures, and E, effect of surrounding environment on mitigation measures, and P is susceptibility of people inside the residing building and intensity level. These are 4 parameters we use to come up with the vulnerability index. So this is a template being used, and from that we identify the indicator and sub-indicator and give a weighting for each using this FGD approach. These are the meaning of the classes and damage description for building a residential area. For instance, very low on the right side, there's the index values, slightly non-structural damage to very high several damage. Similarly, for roads, slightly damaged road and does not affect any traffic problem, and very heavy damage compromising the structure integrity. Similarly, for dams, slightly damaged of them for very low and very high in the index on the right side. And for electrical pylon, we did every one of them. So this is very important because later on, when each owner of the critical infrastructures, when during the maintenance, they can record degree of damage if there is an event or the landslides for future use. So when it comes to the risk assessment, we use just a metric system. Just now, vulnerability index based on the methods. And for hazard, we use a GMG methodology and the maps provided by GMG in order to come up with risk. So this is a geospatial approach because we need to come up with the maps for input data at the top, the available factor, landslide inventory, and landslide trading factor. That one is actually for susceptibility analysis and hazard analysis. That is being used by the GMG. But then my focus will be on the vulnerability analysis. We produce geospatial information for landslide inventory, susceptibility of critical infrastructure C, and also surrounding environment and landslide intensity and population. And then come out with the index.
So you
These
have
are the
3 minutes left. Thank you.
These are parameters we use for buildings and also for roads we identified here, and for dams and from that for pipeline, each of them based on the consultation with all the experts. These are example for the building, we all the weightage, the other parameter we can come up with the index. So the next step is to come up with the geospatial information for each parameters. For instance, for C, for E, I, and P. And then we come up with the vulnerability index maps. For risk combination of vulnerability and landslide hazard, we come up with risk. And we test it for the case study, one of the case environmental. And we develop a tool as well for that. We just select what type of landslide, what type of critical infrastructure, and as a class from that, we can come up with the index. This is an example of the simulations, the meaning of risk. So from that, we can say this guideline can be used by local authority to identify vulnerable critical infrastructure within road critical pilot. The proposed method, however, was strongly dependent on several elements, including quality of landslide hazard map, landslide inventory, landslide damage assessment data, and the experience of the expert. So we propose that this guideline used for other regions, but with the improved standard method for landslide damage recording method. In order we can use it for quantitative approach later on. Thank you very much, Mr. Chairman.
Thank you very much, Dr. Zakaria Mohammed. Very nice presentation. Are there any questions from the floor? Well, if not, then I have a quick question. Well, actually, the good thing to see from your presentation is you have presenting the you've been presenting the risk management, but I'm wondering whether to make it effectively, you have to have the cooperation with the local communities. I don't know how successful for Malaysia to work with the local community in terms of risk management and risk reduction.
Thank you very much. Actually, we have a program under risk communication. Nowadays is under NEDMA, the National Disaster Agencies in Malaysia. We have many programs now is going on, especially related to dams, safety, and also landslide safety. We have done that with NEDMA. We had every year events with the local authority, with the people and with the local authorities. We call it what we call community-based activity. But then we don't have any kind of monitoring using a local community like in Thailand. That is a wonderful activity. We are educating about the people about preparedness if the event of any earthquake or any geohazard in Malaysia. That is going on. It's very active now through NEDMA. Of course, university play very greatest role on that part, as well as private sectors. Thank you.
Well, thank you very much. Please give Dr. Zakaria Mohammed a big hand for his presentation. Thank you, sir.
Thank you.
So now I'll hand over to Professor Dr. Panja Charupsari to chair the session from now on. Thank you very much.
So hope this is the last session, huh?
Of course.
Well, the next presentation will be given by Amy Marina Saleh.
Yeah.
Right. She's Malaysia. She's from Malaysia, and her talk will be given by under the title Mitigation of Carbide Lime Waste and Carbon Dioxide Gas Emission from Acetylene Gas Industry, Feasible Technique of High-Grade PCC Production. Actually, she is a research officer, and she has been working now at the Mineral Research Center, Department of Mineral and Geoscience in Malaysia. She got a bachelor degree in engineering, material engineering, actually from University Saint Malaysia, and she got Master of Science at the same university. And of course, in 2016, she got a doctorate degree from metallurgy, the same university. She has a very wide range of experience, particularly on the development of biodegradable magnesium and zinc-based alloy. And also she also did some research on the high pressure temperature corrosion soldering of microelectronic packaging. And please, Dr. Saleh.
Amy.
Oh, okay. Amy.
Okay. Thank you, Professor Punya. Assalamualaikum and good afternoon to ladies and gentlemen. I am Amy Marina Saleh from Mineral Research Center, Department of Mineral and Geoscience, Malaysia. Today, I would like to share some research findings regarding mitigations of carbide lime waste and carbon dioxide gas emission from acetylene gas industry, feasible technique of high-grade PCC production. Sorry.
Something happened?
Yeah. So, sorry.
You cannot move to the next slide?
Yes.
Oh, okay.
Can you see that?
Yes.
Okay. The global acetylene gas market is currently witnessing a stable growth in producing acetylene gas. Limestone is heated up to 1000 degrees C to form calcium oxide, and then the calcium oxide is burned up to 2000 degrees Celsius, forming calcium carbide. Additions of water into the calcium carbide results in the formations of acetylene gas as a main product and carbide lime as a byproduct. Owing to its high flame temperature properties, acetylene gas is extensively used in numerous metalworking applications such as acetylene welding, cutting, brazing, soldering, and heat treating. Acetylene is also used as a raw material for the production of various chemicals such as polyester, polyurethane, and plastic. However, the productions of acetylene gas results in a formations of carbide lime, which is considered or classified as a scheduled waste under in Malaysia under Environment Quality Act 1974, which is due to its hazardous properties of high alkalinity with pH of 12.5 and unpleasant odor and can cause irritation to skin and throat. This phenomenon of acetylene manufacturing results in two crucial environmental issues. The first one is the rising amount of carbide lime, and the second one is emissions of atmospheric carbon dioxide that increase to over 400 parts per million and continues to increase, which causing global warming phenomenon. According to Malaysian statistics, in 2018, almost 20,000 tons of carbide lime is produced. Thus, this number requires urgent utilization to avert handling and disposal difficulties of the abundant waste. In mitigating the accumulative waste of the carbide lime that is rich of the calcium hydroxide up to 25 to 30%, and carbon dioxide are targeted to be used or to be revolutionized in producing high grade and high profitable precipitated calcium carbonate, which is PCC, where the PCC is the most extensively used mineral filler in various applications. Synthesis of PCC based on precipitation reaction is an important process that is attributed to the significant applications of PCC as a mineral filler. There are numerous commercial use of PCC which can be used in paper making, paint, rubber and plastic, sealant and adhesive, pharmaceutical and skincare as well. Thus, this research targets to use calcium-based mineral in producing high-grade, high-profit PCC to investigate effects of atomizing air pressure on PCC production and to enhance feasibility of PCC production using calcium-rich ionic solution. This is the work methodology for the research methodology for producing PCC, starting with mixing calcium-based mineral and sucrose solution and to form ionic solution. Then the ionic solution is left for 24 hours in order to allow optimum extractions of calcium ions from the calcium-based mineral. And then the solution is filtered. The calcium-rich ionic solution is then continuously separate into a carbonation chamber, and simultaneously carbon dioxide gas is flowed as a main precursor or as a main source of the carbonate ions. This process is called carbonation, where the calcium ion and carbonate ion will react together and precipitate, forming the PCC. The carbonation process is continued until 1 liter of PCC slurry is collected, and then the PCC slurry is going to filter, rinse, and dry at 60 degrees Celsius for 24 hours. Interestingly, from this carbonation process, there were formations of two final products. The first one is high-grade PCC, and the second one is the sucrose solution residue, which economically this sucrose solution residue can be reused for another productions of PCC. There are a few parameters involved for this process. For this current report is atomizing air pressure was varied from 10 to 50 psi. Atomizing air pressure is denoted to the carbon dioxide feeding, and the other parameters, which is liquid air pressure, cylinder air pressure, and concentration of sucrose solution were kept constant. Prior to the PCC production using carbide line waste, purely quicklime was utilized as a starting material in order to ensure the capability of this current technique using ionic solution. Let's go for the research finding. Starting with carbonation time and PCC weight, as can be seen, the carbonation time is increased as a function of atomizing air pressure. This phenomenon suggested that the time taken or the reaction time taken for the complete carbonation process is quite longer with high feeding rates of carbon dioxide. And otherwise, for the PCC weight, initially the PCC weight was continuously increased until 30 psi, but then above 40 psi, the weight is slightly reduced. In terms of particle size distribution, the average particle size of PCC were between 11 to 18 micron, where the closest PCC particle size was attained at 30 psi, which due to the mechanisms of particle intergrowth. This is the morphology evaluation based on the scanning electron microscopy. As can be seen, at 30 psi, the PCC particles were existed in a form of rhombohedral and scanohedral growth, whereas at higher pressure of 50 psi, the PCC structure is more spherical in shape.
Sorry, you have 5 minutes left.
Okay, thank you. Okay, for In verifying the capability of this technique, we use the carbide waste from acetylene gas. As can be seen, the time taken for carbide waste is quite longer, which is 6 to 18 minutes per liter, whereas for the quicklime is slightly lower. In terms of PCC yield, the carbide waste base PCC was only 9 to 12 gram, but the quicklime PCC base is more than 20 gram. This is because the carbide waste contain only 25% to 30% of calcium ions. However, interestingly, by using this technique, by using ionic solution, the purity of the PCC is produced using from carbide waste or quicklime waste. The purity is 98%, which is considered high grade PCC. From this technique, estimatedly 74 tons of 74 tons of carbide lime can produce 100 tons of PCC. According to the scenario in Malaysia, yearly 20,000 tons carbide lime is produced. Then the amounts of massive waste can be converted into about 27,000 tons per year. As the current price of PCC is about 500 ringgit Malaysia per ton, thus 13.5 million ringgit per ton can be earned by revolutionizing the waste to PCC using this technique. And profitability, we also test the PCC from the carbide waste in the real product, which is paper and paint. And the produced product is also tested for the evaluation quality, and all the products pass all the requirement standards, which is MS 1288/2012 for paper and MS 134/2007 for paint. Okay, before I stop, this is a short capture of the PCC production, where as a main user of limestone, acetylene manufacturing has massive stock of calcium-based mineral, including carbide lime waste. Thus, via this feasible technique, those calcium-based mineral can be utilized in producing more marketable high-grade PCC, which is highly potential to penetrate wide range of industries. As a conclusion,
okay, good.
As a conclusion, a few types of morphology of PCC were formed at different atomizing air pressure, high potential of ionic solution to extract CO2 from the waste. Carbide lime from acetylene gas can be used successfully recycled in producing high-grade PCC, and carbon dioxide was used as a main source of carbonate, thus can mitigate excessive emission into the atmosphere. Conclusively, the recycling of abundant carbide lime waste and carbon dioxide from acetylene gas in producing high-grade, high-profit PCC results in zero waste production that not only reduce the waste management costs, but may also increase industrial profits, and importantly, may help to sustain the natural resources and preserve the environmental sustainability. Okay, that's all from me. Thank you. Terima kasih.
Dr. Prinya, just one question.
Okay.
Quick one. No, you. So you don't need that?
Sorry?
Any person from the floor? Well, look like no question, huh?
Okay.
Since we don't have much time, thank you so much. Please join me a big hand for her. Amy, thank you.
Thank you so much.
Next one. The next talk will be given by Dr. Frederick Tating. from Malaysia again, under the title Seismic Hazard and Risk Reduction Initiative in Low Moderate Seismicity Area, Malaysia. He is now the Deputy Director of the Department of Mineral and Geoscience in Sabah, Malaysia. He got bachelor degree from National University of Malaysia and master degree from Kumamoto University in Japan and PhD from ITC University of Twente in Netherlands. He got experience, a lot of experience and expertise on the geological hazard and risk assessment. Please, Dr. Tatin, is that correct? Now the floor is yours. You can start now if you like, unless it's all right.
Please make it to slideshow so that we can see clearly.
Or maybe
It works.
It works.
Go to display. Okay.
Look
okay.
like all right.
And then click swap. Okay. Great.
Yeah, please start now.
Yeah, can you hear me?
Of course.
Yeah, okay. Thank you very much, Dr. Punya, for the kind introduction. So good afternoon to everybody. I'm Frederick. Okay, on behalf of my colleague from GMT Malaysia, so I would like to thank the CCOP Secretariat for giving us this opportunity to present at this prestigious event. So this afternoon, I will be presenting my presentation with the title of Seismic Hazard and Risk Reduction Initiative in Low and Moderate Seismicity Area in Malaysia. Okay. So this is the outline of my presentation today. I will start with introduction, especially the tectonic setting, the seismicity in Malaysia that includes maybe some historical hazards and risks, and the earthquake events that what I call eye-opener events, because this event eventually resulted our government to realize that the need for earthquake hazard and risk assessment. And then the government responses and initiative, and then finally the concluding remarks. Yeah, so actually the main aim for this presentation this afternoon is to share you the Malaysian government's initiative in reducing seismic hazard risk through the population and regulation and policy, and also utilization of some geological and tectonic information. So maybe you have already know about seismic hazard. It's about probability of occurrence at a given place with a given period of ground motion to the earthquake, particularly magnitude that capable of causing significant damage. And for the seismic risk is actually the probability of some consequences of seismic hazard. So to understand why Malaysia is considered as a low to moderate seismicity, let us look at this map. So you can see here, maybe I change my pointer. So Malaysia is located as this box, red box, and actually the Peninsula Malaysia is located at the tectonically stable Sunda plate. And for the rest of Malaysia, that is Sabah and Sarawak, is located at the semi-stable stretch of South China Sea. And Malaysia is bounded by Great Sumatran Fault and Sunda Zone at the west and south. At the east is bounded by the Philippine Trench and several other active mobile tectonic belts here. Okay. So if you zoom at this Southeast Asia, so we may find out that it was subjected to various converging of tectonic plates. For example, at the northwestern side here, so there is a Eurasian plate converging towards this, converging southeasterly towards here in Malaysia with the rate of 4 cm per year. At the eastern side, there is a Pacific and Philippine plates converging westerly at about 10 to 10 centimeter per year. At the western and southern side, this is the Indian Australian plate converging to this to here, this Malaysia, at about 7 to 7 cm per year. And it looks like this area is under compression. And in order to release the compression, I think there's a movement along the fault, maybe activation of old fault that resulted in the earthquake event. So in terms of the seismicity, if we look at this figure, it shows that most of the earthquake epicenters are located at the, the boundary, at the Sumatra Fault, at the Sunda Trench, at the Manila Negros subduction zones. And we hardly found any epicenters, especially in Peninsular Malaysia. But however, this Peninsular Malaysia and Sarawak are actually affected by regional earthquakes and also some localized earthquakes. I will elaborate later. And for Sabah and some part of Sarawak, it was affected by both regional, meaning that from this side, from the Philippine side, and again from local earthquakes, from the local active fault. So we focus on Malaysia now. So this is some of the epicenters of local earthquake, of local sources that have been recorded in Malaysia. And based on the record from 1923 to 2020, about 665 only epicenters have been recorded. And this one is also included aftershocks, and up to there's only about 38 events that greater than magnitude 5, and only 4 events that greater than 6 magnitude. So if you look at this Peninsular Malaysia, actually the local source is related to the activation of old faults, maybe due to the flooding of dams and mega earthquake in Aceh in 2014. And for Sabah and Sarawak, the local source is related to the existing active fault that is within the plates. Okay, this is the location of 4 events that is with the magnitude of 6 and greater that is happened in 1923 here in area here in what we call Lahadatu, and again in 1951 in Pudat, and again in 1976 in Lahadatu, and the latest one is 2015 in Ranau. All is more than magnitude 6. Okay, well, what about earthquake effects? So if you look at this historical earthquake hazards in Malaysia by Layu 1995, actually no, there's no significant effects in Peninsular Malaysia and Sarawak, and then no reported of damage to buildings and houses, and no reported of casualties. Only minor shaking, and also the worst is object falling from cells. But for Sabah, the shaking and intensity is stronger, and there's reported that there's a light to moderate damage on houses, buildings, and structures, and only 1 casualties not related to earthquake, actually due to the shock from the ground shaking. Yeah, this is prior to the 2015 earthquakes, and actually prior to this earthquake, so only 4 events resulted in considerable damage. That is in 2051, 76, 21, and 28. So this is the effect of the significant, I mean, the events that happened in 76, but only cracking, something like cracking, and maybe something like, yes, damages, but not quite significant if you're comparing to the neighboring country. Okay. So this is what I call opener seismic event that was happened in 2015, 7:15 at morning with a magnitude of 6, and this is the most devastating earthquake event in Malaysia and was felt in most parts of Sabah, even in Miri, Sarawak, and in Bandar Seri Begawan in Brunei, and it caused more than 200 aftershocks. And the epicenter of this earthquake is in Mount Kinabalu here, and the red star, small star, is actually the aftershock after the main event. And this is the impact of this earthquake. So as you can see, this is the Mount Kinabalu, this before the earthquake.
5 minutes left.
Yeah, okay, thank you. So this is after earthquake, and you can see the widespread landslides here. And there's some casualties, 18 casualties, mostly the climbers of the Mount Kinabalu. Some damages on walls and cracking on walls and shop malls and buildings, and triggering some landslides and debris flow, and also devastation on natural water resources. Again, you can see here more tree trunks were brought by the river water and clogging and damaging the water intake at this area. So, and also some losses, some resulted in considerable effect on Sabah tourism, especially related to the Mount Kinabalu climbing, as most of the facilities and trails were affected, and the total losses is about 100 million ringgit. So what we have learned from this event? So actually, the devastating impact and future losses from the 2000 events has caught the government off guard, especially in search and rescue operations. The mountainous environment become an eye-opener in the necessity to reduce impact. So what we have learned is the necessity to further investigate and characterize localized earthquakes, and monitoring and predict earthquake system and mechanism, the obligation to incorporate earthquake resistant building code, the necessity to formulate regulation and policy on development in earthquake-prone areas, and the necessity to disseminate information on seismic hazard and risk through public education, awareness program, and maybe drills, necessity to establish standard operational procedures for search and rescue operation, especially in mountainous environment. And this
Less than 3 minutes now.
Yeah, the government response that is, we have given about 12 million to study the active fault in this area, and we have developed the seismic hazard map to be incorporated in our seismic resistant buildings, and we have developed this guideline on development of earthquake-prone areas, and this was carried out by Town and Planning Department, Malaysia. And we have modified the seismic hazard map to be incorporated in seismic hazard management. So this can be used to seismic hazard management, and we have disseminated information to the public through education, awareness programs, seminars, and drills. And also we have established a clear systematic earthquake operation action plan to address earthquake hazard more efficiently and effectively in the future. And we established an auxiliary firefighters teams dedicated to the mountain search and rescue. Okay, for the concluding remarks, So earthquake cannot be predicted with certainty. However, hazard and risk from earthquake maybe can be anticipated with an acceptable accuracy to intensify systematic investigation and assessment of earthquake system and mechanism. And all this information should be disseminated and should be incorporated into regulation and policy and guidelines through public education, awareness program, exercise, drills, and etc. I think based on this government initiative, I believe that it may definitely reduce the impact of future earthquake impacts in Malaysia in the future. With that, thank you very much for your kind attention.
Dr. Prinya, please.
Thank you. In Thailand, many active faults related to hot spring. Do you have any hot spring being identified in Malaysia?
Yes, of course. We have in Sabah. We have a lot of hot spring actually, and also in Peninsular Malaysia, we also have a lot of hot springs. Yes, of course, we have.
What sort of temperatures of the water?
Sorry?
The temperatures of
the temperatures is more than 60 degrees. Well, we have one hot spring in near the mountain, and the temperature is about more than 60 degrees Celsius.
Okay. Another short question. In Malaysian territory, do you have any active volcanoes related to seismic?
No, we don't have volcanoes here. Only ancient volcanoes, or maybe ancient volcanoes, not active volcanoes, because we are very far from the ring of fire.
Thank you.
Another question. I have one small question.
Okay.
What is the most dangerous fault in Malaysia? Dangerous.
Dangerous what? Dangerous
fault.
What?
Fault.
Fault. Okay. Fault. Okay. Okay. There's one fault we just identified. We call it low-level fault. That is, if you can see my screen, there's a Mount Kinabalu. Just below the Mount Kinabalu, there's one line here. I don't know whether you can see or not. So what we call a global level fault. That is the origin of the 2015 earthquake. Yeah.
Mainland. I think it's mainland. No slip rate or recurrent interval.
Yeah, we are still in infancy stage of earthquake. So we just started to learn about earthquake fault, but we still don't know the rate. But as for now, we have installed some equipment to monitor the slip rate. We have installed what we call a GNSS, Global Navigation Satellite System, something like that, to monitor the slip rate of this fault. And hopefully in the future we know the slip rate of this area. I mean the fault, active fault.
Sorry.
Hello.
I think there is no more time for something like this. So maybe if you need some more questions, maybe you can contact Professor Dr. Tatin right away after this. Well, please join me to give him a big hand for this kind of good presentation.
Thank you very much. Thank you very much.
Maybe we should move to the next presentation, which will be given by a geochemist from the northern part of Thailand. And her talk will be on the potential green environmental application of leonardite from the Mammoth mine northern Thailand. She's now the senior scientist working in Mammoth Mine, actually in the Lampang province, northern part of Thailand. She got a bachelor degree from the Prince Songkhla University, and also and the doctorate degree in environmental technology from King Mongkut University of Technology. She got lots of experience, particularly the hazardous waste and utilization of fly ash. Please, Dr. Kanika, the floor is yours now. Kanita, sorry. Dr. Yim, please.
Kanita ค่ะ
Kanita, okay. Sorry, please.
Thank you, Mr. Chairman. Good afternoon, everyone.
Good.
I am going to talk about Mammoth leonardite in the topic of the potential clean environmental application of leonardite for Mammoth mine, northern of Thailand. And my outline is separate for 5 sections. The first is an introduction. The second is objective and the experimental test. After that, we talk about the result, and the last is a conclusion. First, I would like to talk about what is leonardite. Leonardite is the low-length coal derived from the terrestrial plant matter, like the low-length coal, like lignite. In a Mammoth mine, it relies from, it have many big of the overburden, because of in a Mammoth mine, we produce about the lignite for sent to the power plant for the electricity produced. We set up, we produce the production about the lignite about 15 million tons per year. And in the topsoil or the overburden, before we take is the lignite, we found take off the overburden, except the mud of that's maybe 7 to 8 times. So we produce the lignite for 16 million tons. So that's more than 100 million tons of the overburden. Leonardite is found in the outcrop of the lignite deposits in the world. Lignite occur between the layer of clay with the clay layer. It prevent the other mineral from the leaching into the leonardite. So it have the pure separate leonardite. For this slide, I would like to show you about focus on the Mammoth Basin. Mammoth Basin is the northern of Thailand, is far from Bangkok, about 600 kilometers. Mammoth is an open mine and associated with the power plant, power station. At from now, we have the capacity of about 2,400 megawatt. This is the area of the power plant, and near of the power plant, this side, in this side, is the mouth, my mouth of the Mammoth mine. The capacity of it is 15 million tons, and the overburden is 100 million tons. I would like to show you about the activity of the mining. The first of it is the electric shovel. The electric shovel is removal of including the excavation of the topsoil by, and it have a clutch at the clutcher station, and then for the reduce side, and then to transported by the conveyor belt. And another instrument we use the bucket wheel. The bucket wheel is have the for the reduce side already and sent to the conveyor belt. It is a conveyor belt system in a mammal mine. And after that, it's sent to the dumping area. We have a lot of the dumping area in mammal mine. And now, after we finish from the dumping area, we close the plant for the reforest, something like that. And we found that the leonardite is have a high humic acid. It's suitable for the soil emission. After that, we would like to add the something for application for the plant in this study. This picture shows the mammoth leonardite in the separate of the clay. In mammoth profile of the soil, the border, it have a J-seam, K-seam, Q-seam, and R and S of coal. The leonardite that we found in the clay raised bed in this year. This picture shows the lot of leonardite bay of mammoth area. This bay maybe about risk of 1 million ton of mammoth leonardite. For this study, the objective of this study the first is to investigate the characterization of the mammoth leonardite. The second is to understand the chemical structure of the mammoth leonardite. And the last is the investigate of the possibility of the utilization of the mammoth leonardite for soil amendment. My experimental design for the first is for analysis the find out the characteristic of the chemical composition, and the second we use for the humic acid. After we extraction and check for the optimized condition, the base of this for to extract humic acid from the leonardite. And the last is the application of the humic acid for soil amendment. This schematic is show the leonardite sample preparation. If the sample from the site, if it more of moisture, we use for dye is for the first. But if it dye, it can use for the clutcher and pulverizing with the ball mill. And after that, we shift it. The sample that we use is a minus of estimate. The investigation of method after we finish off the humic acid we use for is SEM, UV visible, and FTIR for check the characterization. And after that, we check for the metal or heavy metal by the ICP OES. This schematic is show the extraction of humic acid. Humic acid is suitable or dissolved in the alkali. So in our study, we use the potassium hydroxide. We use the leonardite for 20 grams and use the 0.5 molar of potassium hydroxide for 200 milligrams and sterling the pH at 13. with the is 30% of potassium oxide. After that, the dissolve of humic acid and fulvic acid will be separated with the centrifuge about 500 or 5,000 or 6,000 roots per minute. And after that, we take it, pouring it to form humic acid and set it for the acid, because the acid will be separate humic acid and fulvic acid. And after that, we dyeing it, and this is the humic acid that we extract from the leonardite. At this sample that we go to.
5 minutes left.
Wow. We have a plan at the Memo mine for extract the humic acid. We study, we vary about the pH. We found that the pH about 12 or 13 is the base of the humic percent of the humic acid. Memo leonardite can extract about average about more than 30%, 33% of the humic acid. Then that for time that simulate the base time is about 3 and 4 how is the base of the humic acid percent. And about the pH meter, pH of solution is the base for 13. It found the percent of the potassium hydroxide is 0.5 is the base of the percent of humic acid yield. This picture shows the memo humic acid from the leonardite memo. And we apply for soil abundance. We found that before use of the humic acid, this picture, and after use of the humic acid, we have found many of power we can use for home and use from the communication before nearly of the memo mine, the people that use from our humic acid for this research, if we found it a complete of plant in this. And for the reclamation area of memo, after we dumping area, we use for crop the flower, we use for the humic acid for 50% can reduce the fertilizer, chemical fertilizer. We can save many money of it. The picture show in around the after dumping area, we found the sunflower. That complete flower. And beautiful in a memo area, we can use the humic acid for apply for use for decrease the chemical fertilizer. This picture show from this memo area for use. Our conclusion, we found the chemical composition of the memo leonardite is obtained for either humic acid for use the 0.5 molar of the potassium hydroxide is the best condition for humic acid content to make up to the maximum of the maximum we found 40%, but the average is 25 of the percent of humic acid from memo leonardite. And the best condition that found the pH that 13 times that 4, 3 or 4 how the potassium concentration 0.5 is the base of the humic acid yield. And there can be cost potential add and alternative material for the soil amendment. Thank you for your attention.
Questions? No? Please, Dr. Prinya.
I like to. I thank you very much for your very well presentation. In terms of ranking of coal, with the coal vary from peat, very low rank, lignite, bituminous. Where is your leonardite on that rank?
In memo, lignite is a low rank coal, nearly peat is leonardite. I mean, before from this, let me show.
Very low. Or any kind of coal, something like weather, from weathering of coal, then you get leonardite. Is that possible?
Only lignite before in America, in North Dakota. The first of
leonardite.
Leonard is the first geologist that found the leonardite in the North Dakota lignite mine. And many of lignite mining is found because of the lignite can oxidation with the, if have the contact with the oxygen, it's easier for oxidize. In the bituminous or anthracite, it's very compact. Cannot, it difficult for oxidize. So lignite or peat, it can easy to oxidize. So oxidize to it and bettering to the leonardite. The answer is bituminous or anthracite is difficult. Easier from lignite and peat.
Okay.
One more question, Dr. Priya?
Yeah. Have you ever tried to measure the heating value of leonardite?
Oh yeah. Because of we try to use the mix with the lignite for send to the power plant, and in the borehole when we check out the coal quality, we found that leonardite is below than 100 kilocalorie per kilogram. For my picture, that's I show the big of this. It show the spontaneous combustion too, because of it have the eating value in the bay. This picture show the smoke of the spontaneous combustion because it have the eating value, still have eating value.
Okay, thank
but
you.
Now we protect it with the soil. The soil we protect from the spontaneous combustion already.
Good. No more questions from the floor? So if not, please join me a big hand to Dr. Kanita.
Thank you very much.
Thank you so much. Very good presentation. So let's move to the next talk, which will be given by another Thai geologist from Department of Mineral Resources, and Dr. Virachat Vivek Win. He graduated from Khon Kaen University, and then he continued his study to PhD from University of Tsukuba in 2014. He got lots of experience, particularly field geology, and then he ended up with paleoseismology and become an active fault person. He also interested in landslide as well. So please, Dr. Virachat, the floor is yours now. Can you hear me, Dr. Virashad? Look like you cannot.
Yes, thank
hear.
you, Mr. Chairman.
Okay,
So
good.
today, Mr. Chairman and ladies and gentlemen, today I'm going to talk. Can you hear me?
Yes, yes, yes.
So please, doctor.
Oh, really?
It's already 2 minutes left. Yes.
Say internet issue? What? Internet issue? Okay, okay, go. Coming.
Can you, Dr. Virashad?
Oh, can you hear me? Hello?
Yes, 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 yes.
Yeah, I'm so sorry. It seems like my internet is not so good. So, okay. Can you hear me? I'm ready to talk. So let me talk. Mr. Chairman and
Please
ladies
go
and
ahead.
gentlemen.
Please go ahead.
Okay, thank you, thank you. Good afternoon. Today I'm going to talk about the updating active fault map of Thailand and celebrate of active faults in Indochina regions. Without further ado, I'm right to get start my presentation.
We still hear you,
First,
no problem.
I'm going to talk about the. Is it okay?
Yes. Don't worry, don't worry.
I'm so sorry. It seems to be my internet connection is not good. So first, I will talk about the neotectonics activity of our region, Indochina regions, and then I will give you the result of the paleoseismic data, how to get the active fault data. Finally, I will make a summary the characteristics of the active faults in our regions.
Can you change slide?
No. Oh. Oh.
So can we change? Don't worry, we try to fix it.
So
wait, just wait for 1 second.
Okay.
Almost.
I waste the time. Okay.
So you can wrap up your conclusion.
Yeah, I'm so sorry. My internet connection is not good. So can I talk? Sometimes I talk without the slides. Maybe it's okay. So first, I'm going to talk about the neotectonic and seismicity in Indochina regions. So as you know well, the correlation between the Indian and Eurasian plate in our regions result in the formation of the active faults in Indochina. So the results of this correlation caused the seismic fault in our region. For example, the north-south trending sky fault in Myanmar. Can you see my pointer here? The sky fault, north-south trending, the most active fault in our region, and the northwest trending reliable fault in southern China. The Indochina located here between the sky faults and reliable faults. So after the correction, occur. And sometimes compression zone here generated the northeast trending fault. For example, the Nama fault, Mejan fault, my target area. So this photo, the map showing the epicenter of the major earthquake generated by the earthquake in Indochina region. For example, the earthquake magnitude 6.8 generated from the movement of the Nama fault in 2011. This is the epicenter here, and the earthquake magnitude 6.3 from the Melau faults in northern Thailand. And the last year, the earthquake magnitude 6.2 in the Laos, northern Laos, KDR. So as I mentioned before, we have the major earthquake generated in our region and some damage showing you here in the slides. For example, the damage from the earthquake magnitude 6.3 from the Melau earthquake. You see the crack on the school building, the crack on the highway number 118 from Chiang Rai to Chiang Mai. Also, there some damage in the Buddhist image in the temple surround the epicenter. The lower photo showing the damage from the earthquake magnitude 6.8 on 2011. You see, not only the damage in Myanmar report, in Thailand also report. From these reasons, Thailand and Indochina, including Laos, PDR, Northern Laos, PDR, located in the seismicity zone. Of course, they are seem to be low to moderate seismicity, but we need to clarify, we need to know the characteristics of these data will be useful for the seismic hazard assessment and then identify the risk map of our region. We can apply this data for mitigation the seismic event in our region. So I'm going to talk about the how to get the active fault data. What we call the paleoseismic trenching data. Here, this slide showing the study area. I will focus on only 4 active faults in northern Thailand, including Mejan faults, Uttaradit faults is a part of the Dien Bien Phu faults, the Dien Bien Phu faults in Laos, and Vieng Hang fault zone to the northwest of Chiang Mai Basin. Just know that Vieng Hang fault is the new active fault of Thailand. Later, I will show you the results of my study. So how to get the paleoseismic data or active fault data? Of course, we start with to identify the fault orientation using remote sensing technique, and then we looking for the area. We looking for the geomorphological feature indicate the active faults on the air photo. For example, we need to looking for the offset stream, chartered fault scarp to identify the fault line, and then we make a trench and looking for the evidence of the fault movement in the trench and correct some sample for OSL and C14 dating to constrain the age of the fault movement. So let me talking about the result of study, the result of the study. So this slide show the Landsat image of the Mejan faults in Chiang Rai, northern Thailand. So Chiang Rai in the southern, and I hope you can see it's really clear line of the Mejan faults. This fault length is about 300 kilometers starting from Thailand to Laos KDR. So I will show you the results of our trenching 3 sites, including Ban Pong Khom site, Ban Pong Pak Kham, Ban Pa Teng site. Location of the trenching, something like this. So of course,
we apply the UAV to get the geomorphology to make sure where is the fault trace. For example, here we observe the offset stream, chart the rate, behavior stream, and then we make sure we want to put the location of the trenching here. So this is the fluoride that we interpret. So the results of the trenching at Ban Pong Khom, we observe the fault trace very clear, located between the alluvium unit and colluvium unit here. And also we quite sure we observe the shear structure in the colluvium unit. So we correct charcoal sample we identify the latest movement of the fault is about 4,000 years ago. Not far away from the Ban Pong Khom site, we also dug the trench at the Ban Pong Pa Camp. Here we have the good evidence of the active fault in the trench also. You can see the yellow line indicating the fault trace, and we also observe, we collect sample for OSL sampling, OSL dating, and we identify the latest movement of the fault is about several thousand years ago. To the east, we also get the evidence of the faults here in the trends. The latest movement is about 900 years ago. So from this paleoseismic data, we can make a story, a kind of historical movement of the faults. And of the faults in the trends at Ban Pong Khom, Ban Pa Teng. We not only the evidence of the fault in the trends, we observe the offsets of the Durbis fault sediment. The offset is about 24.5 meters, and then we collect sample for cosmogenic dating. We estimate the slip rate of the Majan faults is about 1.4 millimeter per year. This is the result of the trenching across the Vieng Hang fault, the new active faults of Thailand. So we found that the latest movement of the fault is about 2,000 years ago, based on the OSL dating of the sediment unit near the surface. So we estimate the slip rate of the Vieng Hang faults based on the vertical offset and the timing of reactivation of the faults since 5 million years ago. Move to Laos. We
better wrap up.
So is it okay? Can I move that?
You have less than 2 minutes, sir.
Okay. Here this is the result of trenching at the Ban Hat Khang, Laos. So we found the latest movement of the fault is of 4,000 years ago. But in case of the UA fault or Uttaradit fault, it is about 3,000 years ago. We identify the latest movement based on the C14S dating is very clear thrust movement in the trends. So we estimate the slip rate of the fault something like this. And this is the active fault map of Thailand that I want to show you. This is 16 active faults in Thailand. Also, the Dien Bien Phu fault in Laos. So based on our results, we conclude that something like this: the Majan fault, Vieng Hang fault, Uttaradit fault, Dien Bien Phu fault are still active, and slip rate of the faults in the regions range from 0.06 to 2 milli per year, and indicate that the activity of the faults are low to moderate. And recently, DR has identified 16 active fault zones in Thailand. So thank you very much for your attention. This is my presentation.
Right on time. Dr. Prinya, please.
Thank you, Mr. Chairman. You want me to ask your student? That's fine.
Please.
Thank you very much, Virachat. Very good talk. Can I just make a comment? You,
yes, please.
On your topic, you mentioned about the earthquake in Indochina. And then you go on to the Chiang Rai, Majan Fault, and the Laos PDR. What did you mean Indochina block or Indochina?
No. Indochina area. Northern Thailand and Northern Laos.
That term may mislead some of us.
Okay.
Indochina for us is the Indochina block.
I see.
The Chiang Rai is
the
Shanghai block.
Indochina for geography is the
for geography.
Asia.
Yes.
One question from Belgium.
Yes, hello, Vanessa speaking from Belgium, Vanessa Heijvaart. I have a question, a very short one. Did you think about looking at long-term earthquake recurrence rates based on lake records?
Yeah.
So by coring lakes, let's say.
Yes.
Okay. So are you doing this now in Indonesia or in Thailand or?
I have no chance to study active faults in Indonesia, but I have studied active fault only in Myanmar, Thailand,
okay, and
Laos,
are you doing?
Malaysia.
Sorry. Are you looking at these lakes in Thailand or in Laos? Because this would be very interesting for us.
Thank you very much. Actually, you know, Uttaradit Falls in Thailand is connecting to the Dien Bien Phu Falls in Laos. It's the same fault system, just the name different. So I want to say the slip rate of the Dien Bien Phu and Uttaradit Falls is quite similar. It's about I forgot.
No problem. We can otherwise we can email to each other. We can have an email contact. It's maybe more easy.
Yeah.
Thank you. It was a very interesting presentation.
Thank you very much.
I think no more time.
Yes, I know.
Thank you, Dr. Virachat.
It's not good.
Well, here comes the last topic of our presentation today, which will be given by a researcher from Belgium, Dr. Sophie Verheijen. Is that correct?
Yes, that's correct.
Okay. And she got her PhD degree from Belgium, Rigi University in Brussels. Is that correct? The name of your...
Yes.
Okay. And she got a wide range of the expertise, particularly the geochemical dynamic in karstic areas and also environmental and climate reconstruction, including archaeological context and cave monitoring. Please, Dr. Sophie, the floor is yours now.
Yeah, thank you, Chairman. So hello, everyone. I will present the LIP Screen project that develops LIPS techniques for the rapid screening of critical raw minerals in the exploration, exploitation, and recycling processes, but also to get a better knowledge of the mineralizations themselves. So we are 7 people working together from different Belgian universities and institutes, and we have several collaborations in Europe also. I am from the Geological Survey at the Royal Belgian Institute of Natural Sciences. So LIPS, or laser-induced breakdown spectroscopy, is a promising technique for the rapid and flexible elemental analysis. High energy laser pulses, for example, ablates material, and that can be solid, liquid, or gas, and induce a plasma, which emits specific lights with wavelengths related to the elements that are present in the target material. The spectrometer measures these wavelengths and produces the spectra with spectral lines that are specific for each element contained in the plasma and therefore in the sample. So the technique requires only a minimum to no sample preparation and can be performed in air under normal pressure. And this is interesting to enable the development of portable versions. It can measure a broad range of elements, but an important challenge is to go the way to quantitative analysis, and especially at the ppm level. Another main challenge is to produce comparable results between samples that have a very different matrix. So when measuring different points on a sample, you can create 2D maps, and the spectra created by each point that you measure in the sample is stored with the spectra, with the complete spectra of each point. Is stored in what we call a spectral data cube. And this includes the spatial distribution of each element and the whole spectrum for each point measured. So very rapidly, there is of course a huge amount of data, and automated algorithms are needed to analyze the data and rapidly give the result on the presence or not of interesting elements. This can be done by ground truth testing, where we compare the measured spectra of a sample with the spectra of a reference sample with known composition. So the idea in the LeapScreen project is to get to a very rapid analysis that can detect ppm levels of interesting elements to enable the rapid screening of a multitude of different materials that are interesting for mineral exploration. And we focus on the Belgian lead zinc deposits. Here is Belgium in Europe. The eastern part of Belgium is exploited since prehistoric times for its iron, lead, and zinc deposits. And these ores are the so-called Mississippi Valley type mineralizations. They are set in place related to the Variscan orogeny. So in the 19th century, the Vieille Montagne mines delivered up to 1.5 million tons of lead and zinc ores, mainly under the form of sphalerite and galena, but also smithsonite or a mix between different minerals called calamine. We target different scales, different material, including the waste products of the former lead zinc exploitations and the critical elements that are associated to these deposits. And this, of course, answers a currently important challenge in the EU, but also internationally, which is the resource availability of critical elements. Recent studies, for example, suggested a certain exploitation potential of the Belgian ores for germanium and gallium. But where exactly should these elements be looked for into the samples and in which mineral phase exactly? Maybe there are elements associated with other elements and that are more easily detectable, for example. So this is what we investigate. And first results of the elemental mappings of a zinc and lead-rich sulfide sample clearly show different locations for the different elements. For example, germanium and thallium are located at the same places as iron, for example. And so iron is a good potential as proxy for these elements. The LIPS can also be useful in the monitoring of soils of old industrial areas that needs to be revalorized, and first results detected lead, for example, in these soil samples. More analyses on soils are ongoing at the moment. So most of these mineralizations are situated in fissures and karstic voids in limestone host rocks, and several authors explain that the ores filled available karstic voids. However, other voids exist just beneath of it that are not filled by these ore deposits. For example, in 1903, a former coal mine gave access to this karstic void that was filled with sulfide ores, zinc ores. And just beneath, a few meters of rock away, there was a very big cave, an empty cave without these mineralizations. So up to now, these observations does not fit very well in the ore deposition and evolution model that we have in Belgium. And so the LIPS analysis should help us to get some information on the different precipitation steps of the ores themselves and the eventual relation with the limestone host rocks. And as such, increase our understanding on the ore genesis and the relation with the karst genesis and evolution. So the problem is that most of these mines are not accessible anymore because they collapsed. But fortunately, other regions in Belgium contain still accessible old lead and zinc mines, although they are less important. And for example, in the Famenne-Ardennes UNESCO Global Geopark, which is the only one, the only UNESCO Global Geopark we have in Belgium at the moment, several mines are still accessible. And in fact, these mines are caves that were emptied of their ore content during the previous centuries. So they are therefore very valuable to be investigated in our LipScreen project. And to conclude, also the UNESCO Global Geopark, Famenne-Ardennes, offers, of course, for scientists an efficient large public communication platform to create awareness of the origin and the need and the sustainable exploitation of raw materials and of ores. So for further information, I can invite you to have a look of our website. And you can also contact us if you want to collaborate. Thank you.
Oh, very good. Thank you. We still have about 2 or 3 minutes. Can you give us some kind of conclusion?
So, well, one of the conclusions, as you saw, is that we have first results. I think this is the main conclusion, that our first results show that the LIPS technique that we use is very valuable in finding there where the elements are in the different samples. And we see very clearly that they are located at certain places. So this will help us in first finding these very critical elements like thallium and germanium, for example, in Belgium, in waste material, in old mines, maybe in other places in Belgium. So this is very valuable. And the second point is that it will help us to understand the different phases here of the mineral deposition, and so help us in the understanding of the mineralizations in general in Belgium. I think this is the main conclusion.
And this is just the qualitative analysis, not the quantitative analysis. Is that right?
That's right. So for the at the moment, we can detect samples at the ppm, detect elements that are at ppm level, but we need to process still the ground truth testing. So we need to compare these results with results from samples where we do laser ICP-MS. And so where we will have a very good idea of the content of these elements in some samples, some very comparable samples. And then we can compare our samples with the sample we know very well, and then we can go to a quantitative analysis.
Mm-hmm.
Yeah.
Thank you, thank you.
You're welcome.
Have you tried to detect any gold or precious metal at all?
At the moment, no, we didn't try to have gold, but in these samples there is probably no gold, but we can try this on other samples in Belgium.
Very good. Dr. Twachai, you have another, you want to ask something? No? Okay. Some other persons? No, please.
Okay. First of all, thank you very much for the contribution of the Belgium, both the Director Vanessa, and then your presentation is very encouraging for us to having that kind of thematic session. And then my question is, it's very important tool to, actually I'm not the mineralogist, I do not know very exactly, but the very useful to create to find out or screening some critical minerals. So my question is that you have used that tool to screening for commercial critical minerals in your recent researches or not?
So we are at the moment we are doing the ground truth. So we didn't screen a big amount yet of these minerals. This will be done, I think, in a few months. We are finishing, in fact, the LIPS settings, so the development of the instrumentation and the exact settings that we need to very well analyze these type of samples. Then we will do the ground truth, and then we will start the screening on a huge collection we have at the Natural Sciences Museum. We have a huge collection of these old ores that were exploited in Belgium. And so we have a huge collection of ores from different parts of Belgium. And the idea is to screen all these samples to see if one place can be interesting to exploit for these critical elements, which were less studied up to now.
All right.
I'm okay.
You're okay now?
But
you want some?
Okay.
Dr. Prinya, please.
From your last slide, the features of the elements look to me like a replacement.
Last slide.
The slide you show us. Is it a replacement or cavity filling type of ore deposit?
What do you mean by a replacement of another element, you mean?
Yes, the replacement in carbonate rock or just infill in the cavities of limestone.
It's so the sample that I showed you, it's zinc and lead sulfide. And it are bands of sphalerite and galena. And so the elements are probably, some of these elements are probably replacement of other elements in these sulfide, so of zinc or lead. But the whole sample is filling karstic voids, yes. So it's very, in Belgium, all these lead and zinc ores are associated with karst development. And in fact, they are filling also the fissures were open, that other scientists could prove that these fissures were already open when the ores came through it and filled open karstic voids. So there is some strange thing because we don't understand very well how they filled these voids and when these voids were created, when the filling was done, and why we have open voids together with filled voids. So this is the challenge to understand this also.
It looked to me like a multiloidal texture of the rock, of the minerals, of many hydrothermal minerals.
Yes, it's possible. Thank you for the hint. I mean, we will have a look at this.
Yeah, thank you.
Any more questions? Well, if no more questions,
Very quick one.
Right,
very quick one. Actually, you said that this LIPS can analyze the sample very rapidly. So my question is, how rapidly? so for example, 25 minutes, 5 minutes, well, maybe 1 hour.
Yeah. So if you do 1 point, it's immediately, it's second or microsecond, and then the spectrum is given directly. When you have to do the 2D maps, and then it depends on the resolution you want, of course, you can do it in a quarter of an hour or in a bit longer if you want high resolution maps, but it's really very rapid. Yeah. So that's why it's interesting for the rapid screening, even if probably to screen, because as you saw, to detect thallium, for example, it was not by point. We detected the thallium thanks to the 2D maps. It's only by making the 2D maps that we saw, but there is a very thin layer of thallium. So that is also the interest, is to be able to make the 2D maps quite rapidly. And so we are thinking about the rapid screening of all these samples. Probably we cannot make for all the samples large 2D maps, but if we can just make one strip, for example, a thin strip of it, then it can go quite rapidly, and then we can see all these very precise small elements that are at ppm level, in fact.
Just a quick question, Titi again. Wondering whether how many samples or specimens that you've been working on, and how many deposits, location that you've been studying using the same technique?
Well, so the locations in Belgium, we have over 100 mines. Yeah, so we have samples from over 100 mines. We think that from the collection, we are targeting in a first step 200 samples from a minimum amount of 10 places or something like that, or maybe even less, to have a good first batch of comparable samples.
Will that be by any chance that you come to Southeast Asia or visit some of our member countries and come and have a field study with us so that we can cooperate? Thank you.
Good idea.
Good idea. In 3 or 4 years, at the end of the project, when everything is working fine, we come to your place.
We have a lot of caves for you to explore.
Yeah. Thank you. Fine.
Happy, everyone?
Yeah.
Look like, eh?
Yeah.
Any more questions? No? I have one quick question.
Oh, yeah. Oh.
Well, in this case, you probably need a very good mineralogical standard, or unless you don't need at all. Please.
Very good question, because that's probably the weak point. Also for laser ICP-MS, for example, especially when you are looking at carbonates, it's quite difficult to get a very good reference sample. We know that at the moment at the University of Nancy, I think there is a team, they are trying to make such a reference sample for metal ores. So on zinc and lead sulfides, with especially for the platina group. But we hope to extend eventually these samples to see if we can collaborate with them. But we will try by doing these ground truths, because that's related, of course, by doing these ground truths and by comparing. We want to make analysis on one reference sample and to make very extensive analysis on this sample to make it a reference sample, because at the moment there is no of such completely similar sample that exists as a commercial reference sample, for example.
Thank you very much. This is a very good answer. Thank you so much, Sophie. Okay, maybe please, Secretary.
Thank you very much, Professor Dr. Panjacharusri. representative from the Geological Society of Thailand for kindly share the session, the very last question of this CCOP 2020 thematic session this year, and also for myself to step off as a chairperson for the session as well. And now I'm an MC. So as an MC, I would like to invite Dr. Young Julie from CCOP Technical Secretariat Director. Please say something before for the closing of the thematic session. Thank you very much.
Okay, I think this 2 days thematic session in line with the 56th CCOP annual session was very successful. So under the theme of the geoscience toward the new normal and future Earth, we have touched very important aspect of the geosciences. Then I see the real big silver linings and then hopes during the session. First of all, I have witnessed that we have something like 200 participants through the online and then YouTube. So, and then also I have witnessed that the very strong intention of all the presenters and speakers who really wanted to continue our geoscience job in order to save our Mother Earth. So it is a very good hope for our future. And secondly, I just have calculation of all the speakers, and then found out that we have something like 30% of women speakers, presenters, and then more than 50% of young generations. So it means we have very bright future. So I really appreciate all the speakers and presenters and courses who contributed this CCOP technical session. And then my special thanks goes to the chairpersons and co-chairpersons, 8 chairpersons and co-chairpersons who really dedicate to for their really very well and smooth management of the session, which really makes our thematic session very, I think, successful. And then I also give my gratitude to the DMR for co-organizing this important thematic session of CCOP. As I already mentioned, and then I, of course, as I already mentioned, I really hope that we can see each other in person in the near future for occasion of the CCOP meetings or other occasions. And then I really appreciate all the participants. Thank you very much. Kokukap.
Thank you very much. So it's time to say goodbye.
This is the way to goodbye.
Thank you. Waving goodbye. Good night.
Oh, thank you. Oh, you have 2 rows.
Thank you.
Bye bye. Bye bye. Bye bye.
Okay, we invite everyone in this meeting room to have a group photo.
နှစ်ဦးကဟိုတည်းလေးဦးပေါ့ကွာနှစ်ဦးကဟို16ထဲမှာပါလားမပါဘူးမင်းအဲ့ဒါ18ဖြစ်တော့ဟမ်သူ့ဘောက18ဖြစ်တော့အဲ့ဒီကူငါဘာလို့16ပြောတော့ဟုတ်ပြီအဲ့ဒါကလည်းလိုက်ကြည့်မှာမဟုတ်ဒီတိုင်းမှာထားတယ် ရရတော့ကျူးထူ